way. The second is event processing. We need to process those events one by one and enrich those events. Third is we need to store those events and finally visualize those events in a visualization layer. I'm going to discuss all these four components one by one. First is event flow. A general event flow looks something like this. You have a set of producers and you have a set of consumers which are interested in consuming those events. And you need a queuing message broker or some queuing solution in between which can uh, facilitate this event flow. So the requirements for this solution are, we need some solution which can provide low latency, high throughput. It should be able to handle like fault tolerant. So if there are any failures at the end of like producers or consumers, it should be able to handle that. It should provide some message delivery guarantees, like ordering of the messages, for example, like which event happened before the second event, or the ordering needs to be maintained in some cases. Also, the delivery guarantees like at least once, exactly once, or at most once. These delivery guarantees varies from use case to use case. The last one is like scalability. It needs to be scalable to handle like billions of events per second. So the solution I'm going to discuss over here for event flow is Apache Kafka, which is sort of like the de facto standard in the industry these days and is used by many big companies. So how Kafka works is it has a set of like brokers, and these brokers have like partitions for different topics. So each topic is divided into multiple partitions, and there are multiple producers, and each producer can produce events to multiple partitions. Events are stored in a partition in a sequenced way, and each event is identifiable by an offset, which gives you an ordering guarantee within a particular partition. You can also have like multiple consumers which will consume events from these partitions in a sequenced way. Uh, there can also be like multiple consumer groups to consume those events into like multiple consumer groups. Each consumer also tracks its own offset so that like if there is a failure on the consumer end, it can come back again and start reading messages from the last good known offset. So to summarize, there are like the Apache Kafka, it provides low latency, high throughput. It has like message delivery guarantees of at least once. The Kafka team also introduced exactly once guarantees in their latest release last month. It also has a reliable design to handle failures, which with like having the message acknowledgements between the producers and brokers. You can configure data replication on brokers for broker failure, and consumer can read from like any desired offset, and they can keep track of their own offsets. The next layer is event processing, where we want to process the event. There is some source where the event is happening. We want to consume those events, process it, and then produce that event to another sink. So consume, process, and produce pattern. What we want to achieve from this is we want to enrich and transform those event streams, apply some business logic for example, like filter nulls. In our Wikipedia edit stream case, enrich those events by adding the geolocation information. You might also want to apply some windowing logic, or maybe like join multiple streams into a single one. This also needs to have like failure handling and scalability aspects. So there are many solutions out there in the market. For example, Apache Samza, Spark, Flink, Apex, Kafka Streams, and Storm. The one I'm going to discuss over here is Kafka Streams, which works very well with Kafka. So Kafka Streams is just a lightweight streaming library embedded with, shipped with the Kafka releases. So it processes an event at a time. It also has like operators for stateful processing, like windowing, joining, aggregation operators. It uses a local state, which uses RocksDB underneath to store the events. And this local state is also backed by a Kafka changelog topic, which means that like this changelog topic is used for failure recoveries. So if you restart your Kafka stream application, or if there is any failure and it gets restarted, it can read that changelog from Kafka and replay those events and create the local state again. You can also scale it and run it in a distributed and fault-tolerant manner. Uh, if you compare it with a Kafka consumer, it is a higher level, which is like faster to build any sophisticated app, and at the cost of like it provides a little bit less control with like very fine-grained consumption. If you need that, you can use like low-level consumer APIs. So for the Wikipedia edit stream, here is like a simple code which does like the processing in 3 steps. The first step is it reads the data from a Wikipedia raw stream, which we are getting from the Wikipedia. It reads that data and builds a Kafka stream object. So on that Kafka stream, then in the second step, it parses those events, matches those events against a pattern, parses those events in a Java object named Wikipedia message, and then then it maps and processes these events, add geolocation information to those events, and filter any events which are like, for example, like null and like any empty strings. Finally, it produces those events to a Wikipedia enriched topic, which from where our data store can now consume those events. So the next piece is the data store, which is also like one of the most critical pieces in this pipeline. So the data store needs to have like to power an interactive dashboard, it also needs to have multiple requirements. So it needs to be able to first ingest streaming data, because we are talking about creating dashboards on data streams. So it needs to be able to consume those events coming from a streaming way. Then it also needs to make those events available for queries as soon as those events are ingested into the data store. The second requirement is, because we are powering dashboards over here, it needs to provide like sub-second query response times so that those dashboards feel interactive. And it also needs to, because we don't know what the user is going to query, so it needs to support like arbitrary slicing and dicing of the data. Also like, as we are visualizing the data, what we are interested in is providing like summarized and aggregated view of your data. And the same requirements of scalability and high availability needs to be there. So the solution I'm going to discuss over there for this is Druid, which I work on. And so Druid is a column-oriented distributed data store, which can provide sub-second query times. It has support for both like real-time streaming ingestion as well as batch ingestion. So you can do batch ingestion via Hadoop or Spark, and also do streaming ingestion from like multiple data sources. You can like either push data to Druid or like pull data from Kafka or like any other messaging broker. It supports like arbitrary slicing and dicing of your data, it uses concepts like automatic data summarization, approximate algorithms to provide you like fast query response times. It has been like scaled to petabytes of data in production and is highly available. So now I'm going to discuss the suitable use cases and how Druid handles like this much workload, and how it is internally works, and how it is able to provide those sub-second query times. So the suitable use cases are like powering interactive user-facing applications, which we are discussing in this talk, arbitrary slicing and dicing of your large data sets, user behavior analysis, like measuring distinct counts, how many unique users visited my website in last 1 week or last 1 month, doing retention analysis, like how many of my users were retained in this week as compared to previous week, doing funnel analysis, A/B testing, and those kinds of use cases, user behavior analysis. So what it is not very good at is, if you are interested in dumping the entire data set. It is good if you are trying to get an aggregated view or like summarized view of your data in the form of queries. But if you are trying to do and dump the entire data set, like since it's columnar in nature, it is not very good at that. So coming to the storage internals on like how Druid internally stores the data. So Druid internally stores the data in the form of segment files, which are partitioned by time. So I can have, like, for example, in this figure, I have my segments partitioned by each day. And so for Monday, I have different segment. For Tuesday, I will have different segment. Ideally, the segment sizes are smaller than like 1 GB in size. If your data for a particular day is larger than that, you can even create like multiple shards for that particular day. For example, on Friday, we have 2 different shards. So these time-based slicing provides Druid the ability to filter your segments based on the time range you are querying. So for example, if I'm interested in only visualizing events which happened in last 1 week, I can quickly only scan those segments which are corresponding to last 1 week of that time range and provide you the results, rather than scanning all the different segments. So coming back to our Wikipedia example, this is how our data looks like after being enriched when it is sent to the data store. So the data has a timestamp of when that event was edited, which is the first thing. Then it has some dimensions, and those dimensions are, for example, like which page was edited, which language the edit was being made, which city and country the edit was being made in. Then there are some metrics about like how many characters were added, how many characters were deleted in this particular edit event. So now I will discuss like the various techniques that Druid employs, Druid uses in order to provide fast query times. The first technique it uses is data roll-up or data summarization. So by that, what I mean is, if in your use case, you are, for example, in your use case, if you are only interested in querying your data aggregated by an hour, so what you can do is you can provide that at the time of ingestion to Druid that I'm only interested in aggregating data by hour or any further granularity. I'm never interested in querying data by, for example, like by each minute or looking at events which happened in each minute. So in that case, what Druid can do for you is it can summarize your data. So for example, these first 3 rows, since they all happened in the same hour, and you are always going to query me data aggregated by an hour or a coarser granularity. So what I'll do is I will just summarize all these 3 rows into a single row and store that there were 3 edits being made. And these were the sum of added, deleted, min added, max edit. You can define all those metrics that you want to compute at the ingestion time. And so this reduces your data size, which needs to be scanned on the query time by like many folds, depending on like how you are rolling up your data. This helps with giving faster query times. The second technique is dictionary encoding. So instead of storing the raw columns as it is, what it does is it creates dictionary encoding for these columns. So what it will do is it will assign IDs to each of the values for these columns. For example, for this page column, we have Justin Bieber, Kesha, and Selena Gomez. So it will assign IDs of 0, 1, and 2. So instead of storing the repeated strings, what it will essentially store is the dictionary, and then the column data, which is just a sequence of those IDs compressed using different encoding, different compression techniques. Similarly, like each of these columns are compressed using this dictionary encoding technique. The third thing it uses is bitmap indices. So it creates a bitmap index for each of the value which is being stored. For example, like in this case, Justin Bieber, that appears in first 3 rows. So it will create a bitmap index saying that having the value 111 wherever the Justin Bieber is present and 0 in the rows where it is not present. Similarly, it will create these bitmap indexes for like all the all the values in your column. Now, when you try to query and filter your data, what it does. For example, I query for like any row which has either Justin Bieber or Kesha. So since it already knows in which rows Justin Bieber is present and in which rows Kesha is present, so it can just do a bitmap or to compute the final result set. And then it will only scan those rows which needs to be scanned in order to answer your queries. So the data filtering is essentially just doing some bitmap or and operations into it. And these bitmap indexes are compressed with concise or roaring encoding to compress the size, to reduce the size of these bitmap indices even further. The next technique it uses is approximate sketch columns. So generally you have like user IDs in your click data, or you have like long page URLs. So, and you're not interested in most of the cases, you're not interested in looking at those individual user IDs, what those individual users are doing, but interested in getting some aggregate information about that, like how many unique users visited my website and things like that. So for those unique users and distinct counts or like retention analysis kind of things, you need not store those exact values. What you can do is you can store approximate sketches, which can be hyperlog or like any other data sketch, which supports these type of computations. So these data sketches reduces the size of your data even further. So instead of storing the row columns, what you do is you just store a sketch object, which can do computations like distinct. For example, if you store hyperlog, you can do like distinct count and things like that. To summarize, to get a bit more details about like approximate algorithms, you can store sketch objects instead of raw column values, which gives you also like better roll up, because you can roll multiple, instead of storing individual values, you are storing like single aggregated object for that particular column. You can have, you'll get like reduced data size. You'll also, the use cases are like approximate distinct count, approximate histograms, funnel or retention analysis. There are certain limitations to storing these sketch objects. Obviously, since you are not storing the raw data, you cannot do like exact counts in this fashion. And you also cannot filter on individual row values if you are using approximate columns. Coming to Druid architecture, so this is a diagram showing like Druid architecture. So we have like, first of all, we have streaming data coming in. Then there is an ETL system, which is massaging and enriching those events, transforming those events. And finally, those events are being sent or consumed to by the real-time index tasks. So these real-time index tasks, what they do is they keep an in-memory state of the events as soon as they receive it. So they create a write-optimized in-memory data structure, which can be used to serve queries. So now, at this point, if someone asks for the data, it can provide the data in the query results. Periodically, what those real-time index tasks does is they convert that write-optimized data structure into a read-optimized immutable data structure, which are the final Druid segments, and they hand over those segments to the deep storage. What they do is they persist those segments to some distributed data storage, which can be like S3, Cassandra, HDFS, or any other network file system. It just needs to be available for all the nodes. From this deep storage, there are another set of nodes which are called the historical nodes, which loads this particular data segments, and then memory maps those segments and serve queries on top of those segments. So periodically, the data is handed over from the real-time nodes to the historical nodes, and these historical nodes can then handle historical data, which is immutable in nature and can serve queries on top of that. The historical nodes, they are the main workhorses of the Druid cluster and serve queries. There is another set of nodes called the broker nodes, which just keeps track of all the data, all the segments, and on which nodes those segments are present in the cluster. What they do is they have the ability to scatter and gather, to scatter your query, to break your query into multiple segments, send them to multiple real-time as well as historical nodes, gather back the results from these nodes, and provide those results to your query layer. Just to see like the flow of an event, for example, an event happened, it was enriched and then sent to the real-time nodes. From at this point, if a query comes, this the event will be served and visible on your dashboard via the real-time nodes. After a certain point of time, these real-time nodes will hand over this particular segment to the to the deep storage, from where it will be loaded on the historical nodes. From the historical nodes, now if since like as soon as the historical nodes loads the data, it will announce that it has loaded this particular segment, and the real-time nodes will drop the data from its memory. And now if a query comes, it can be served from the historical nodes itself. Just some quick facts about Druid's performance and scalability on like how it looks like in production. So Druid, the largest cluster is hosted by MetaMarkets, which was also the company which initially started Druid. So that has that ingests around like 300 billion events per day. Jolata uses Druid for computing around like 1 billion metrics per minute. There is the largest cluster at MetaMarkets is around like 200 node cluster. And the largest hourly ingestion rate in terms of data size is reported by Netflix, which is around 2 terabytes per hour. Here is a list of like some companies which use Druid in production. There are a bunch of different companies over here which uses Druid in production at like various scales and various sizes. The next layer is the visualization layer, where we have the data in a data store which can provide subsequent queries. Now we want to create dashboards and visualize those events and analyze them on a dashboard. So for that, the requirements are we need to have a visualization layer where we can create the dashboards, which has the rich dashboarding capabilities. Generally, in the organizations, we do not have data in a single data source. We have data spread across multiple data sources and coming from like multiple sources. So it should be able to also query like multiple data sources. And since it is a user-facing application, it needs to have a security and access control. It also needs to be extensible enough so that you can customize it for your own use cases. So the solution I'm going to discuss for the visualization layer is Superset, which is a Python-backed Flask application, which has authentication and uses pandas for like rich analytics. It uses like SQL Alchemy for its SQL toolkit. For the front end, it uses React and NVD3, and it also has a deep integration with Druid, so that like it can generate native Druid queries and which are optimized and parse back the results and serve those results in the dashboard. So just to show like some of the dashboarding capabilities, it has support for like various visualizations like tree maps, sunburst. It also has many visualization layers. In fact, like I can show you guys some of the other dashboards, some of the other sample dashboards which has those visualizations. For example, this is world's bank data dashboard, which has world's health and population data. So you can see there are like map visualizations. There is like this sunburst visualization of breakdown on like of the rural areas. You can have different like line charts. You can have tables and like stack charts, bubble charts, lots of visualizations, and it also provides an explore view where you can see what all visualizations are there. Yeah, so these are all the visualizations that Superset supports today. It is also extensible, so if you want, you can add your own custom visualizations to this. And it is very easy to like create dashboards with Superset on like multiple data sources. So you can have your data sources defined. You can connect like multiple data sources. So I have one SQLite database, and on the Druid data sources, I have these like different Druid data sources connected to this particular superset instance. So yeah, coming back to the slide. Uh, so yeah, it has lots of visualizations which you can use and customize for your own use cases and create dashboards. Uh, yeah, so to summarize how this whole Wikipedia dashboard was working, and so essentially, we had like this Wikipedia streams coming in. We were using a simple Java application using like Kafka Connect APIs to just dump all the raw events which we are getting into a Kafka topic named Wikipedia raw. Then we are reading. Then we were using Kafka streams, and we created a IP to geolocation processor in the Kafka streams, which was reading these events from Kafka and writing them to another topic named Wikipedia enriched topic. And from this topic, we were then pulling data into Druid using Druid's Kafka indexing service. And finally, we were querying Druid to visualize all those events in Superset. These are the link to the project websites. You can go to these websites if you need like additional information about any of these projects. Uh, with this, I will end my talk. And I would also like to announce that there is an off-the-record session on experiences and challenges in working with Druid. So if any of you are using Druid in production and are facing like any issues or are interested in knowing like the future roadmap and discussing the challenges that we have faced, please join me tomorrow at like 3:25 p.m. in room 1 for like further discussions. And now I'm open for questions.
Questions? Nishant, thanks for that wonderful session. I have a couple of quick questions. Hello.
Yeah.
Okay, Nishant, I was just thanking you for the session. My question, two questions really.
You're now.
Am I now?
Can you hold the mic closer?
Okay, is it better now?
Yeah.
Okay, thanks. So Nishant, two questions on Druid really. So you mentioned, how you would actually decide on a roll-up frequency as a design element, and the data gets rolled up on that roll-up slice that you've taken, right? You mentioned hourly in your case. Often there are scenarios where you want the roll-up, but you also want to have access to the raw data. Are you able to model those type of scenarios with Druid as well?
So you want the roll-up to happen as well as you want the raw data.
That's correct. Yeah.
Yeah. So essentially, like it's not a cube building solution where you build like multiple cubes actually. So what you can do is you can have your data not rolled up by any granularity, and then as your query comes, so the brokers also have a concept of caching. So they can cache your aggregated results for each segment. And if you requery that particular aggregated data set, it can look up into that cache rather than actually processing your query. So this caching layer actually helps with these kinds of scenarios where you want to query like multiple granularities, but you do not want to roll for that particular granularity. Though you will pay for the storage size, for the extra storage needed to store that event.
Question?
Hi. How does that Apache Kafka streams and Flink, how do you choose that between these two?
What it was about Apache Kafka Stream. What was the question?
And there is Apache Flink also. Flink.
Yeah.
So how do you choose between these two?
So actually, like, I'm not going to like compare all these ETL engines. So
No, in particular, the time
in
series.
particular, like, I haven't worked with like Flink, so I cannot like comment on that. But talking about Kafka streams, it is like you can have your processing in like multiple stages, and which is like pretty good and which is pretty lightweight. So if you are moving towards like micro containers or Dockers or any of these kinds of solutions, you can use that if like an e-commerce website and you have different users visiting that particular website. So you store you get those user IDs in each of the events, right? So those user IDs are of the order of like billions of cardinalities, right? And what you are interested in, instead of knowing like this particular user visited this page, instead what you are interested in knowing is that how many users visited my e-commerce website in last 1 week. So those kinds of questions can be answered by these data sketches. And one example is hyperlog objects. Like you can create hyperlog objects and store that. The second is another library created by Yahoo for like data sketches. So if I compare both of these, hyperlog is not very good at like doing intersections. It is good at doing unions, but not at intersections. So for intersections, the other theta sketches library contributed by Yahoo, that works pretty well. So intersection is needed for use cases like retention analysis and things like that. Yeah.
Hi, I'm starting on a similar activity. So this session is really helpful for me. Now I have two questions. One is how does it compares to ELK stack? If I look at the whole framework.
So honestly, like I haven't done any benchmarks, but there were some benchmarks done by the team at Netflix with the ELK stack, and what they found was like for search kind of search use cases, uh, that was pretty good. But for if you are interested in like aggregating, doing aggregates, uh, it, the ELK stack needed like much more resources and was getting like much more costlier in terms of both like query latency as well as the hardware requirements. Uh, there is there is like one blog, one like complete post on the Druid query forums, Druid user forums on like this topic. So you can also like search for that and for the exact numbers that they got.
Okay, okay. And does superset allows to change the query? Like how difficult it is to write a fresh query?
Superset allows to create a query.
Yeah, query.
It's pretty easy actually. So like superset has this like concept of slices. So you can just like for example, I just selected the data source. You can select your visualization, for example, pie chart, and then you can pass in some like group by keys. Uh, like for example, I want to group by country name and then query that. So yeah, here is like, let me just, yeah, this is like,
One last question.
so this is one way, and the second way is the SQL lab. So it also has an SQL lab where you can like pose your SQL query and get your results.
One last question. That side.
Yeah. Is it good for mutable data? For example, transactional data which has some columns
So
changing.
it is good for like OLAP use cases, not like OLTP use cases where you have like transactional flows. So it right now what it does is it treats your past historical data as immutable. And if you want to make edits or changes, what you need to essentially do is reprocess the data for that particular interval. So since the data is time sliced, so you can replace segments for like any selected interval. For example, like there was like some bug and I want to process like events for last 1 week. I can just reprocess that in a batch fashion via Hadoop, MapReduce job, or via Spark, and then create newer segments which will replace those older segments.
That may be good for one of a kind of time where things have gone bad. But if something is changing forever, for example, last say 2 months of data is always keeping, keep changing, then maybe this might not be a good.
I mean, can you define more on?
So,
like,
for example, I have a transaction which has different status. For example, transaction initiated, then in process, success, failure, and then I want to know
so
kind of.
there are like multiple ways to like just like model this data set. So you can model this in terms of like event streams. So transaction at this time, it's state, old state, and new state. So if you just have this as an event stream, so this now becomes an immutable data, right? And if you want to query the final state, you can just query the latest event and filter by the latest event, you will get the latest state. And by this model, you also get the historical states. So you can see that like instead of just storing the current state, you can store the old state, new state in a event-based way, right? So there are ways to like model such data sets also.
Thank you.
And I mean, if there are any further questions, we can take that like tomorrow in the off the record session.
Yes, we can take this discussion offline. Thanks a lot, Nishant. So we will now take a break for tea and be back here by 12:05 p.m. sharp. There are a few short announcements. There's feedback form at your seats. Your feedback makes us help build these conferences better. So please fill the feedback forms and drop it at the counter. There are certain bags for the feedback forms. Also, you can pay for your food at the vendors by using Paytm, or you can buy tokens from the token counter. We accept card and cash, and cash is not accepted by the vendors directly. So you can either pay vendors by Paytm or token, and you can buy token from Hasgeek counters. The merchandise counter in the lobby is open from 10:30 a.m. to 5 p.m. You can pick up your prepaid t-shirts over there. And also, we are inviting flash talks today from 5:10 p.m. to 5:40 p.m. It could be anything, a 5-minute presentation about an open source project you have worked on, some tips and tricks, some experience you would like to share with people. Also, the code of conduct is there on the Hasgeek website and should also have been emailed to you along with the ticket. Go ahead and read that code of conduct, make sure you're not violating any of these. To submit a flash talk proposals, you can contact me as a hall manager or any of the 3 people sitting in the right side front row seat. Thank you. We return here at 12:05 p.m. sharp. Talk by Gaurav Godwani from DataKind. He's going to talk about transforming India's budget into open linked data. Over to Gaurav.
So good afternoon, everyone. Today I'm going to discuss about how to transform India's budgets into open linked data. So let's see, what does budgets mean? So budgets reflect the priorities and values of the people of its state. It tells about the promises of the government, and it tells about how much they are achieved. So it are so-called moral documents. It has been referred as moral documents across several geographies. There is one story linked here from Vox.com, a proper data journalism website, talks about how in US they consider them as moral documents. But in India, the state of budget is something like this. They are very hard to access, very difficult to comprehend. It makes us really difficult to analyze them in time and make our priorities accordingly in terms of analysis, reporting, and see where the government priorities are fitting in. So on your left, you can see budget of BBMP, and on the right is budget of Karnataka state government. You can see the disparity in the format and the structure difficulties involved there. So major issues with India's budget are, most of them are unstructured PDF documents, difficult to parse, difficult to analyze, limited availability of budgets online. For example, Tamil Nadu government doesn't publish budget for more than a year on their website. So suppose I have to go back and see what was happening in last 2 years or so, I can't do that. So that's a major issue. Inconsistent formats. Each of these government bodies keep changing their formats as and when they change a new vendor or have a new addition in terms of policy or a major change in terms of politics, so on. No metadata. So none of these websites give any metadata. So we don't have detailed information about the currency, detailed information about what's inside the budget document. So you have to really go through thousands of pages to understand the key keywords related to that particular document, which are a pain. And lastly, inconsistent and incomplete budget codes. So you can see budget codes as unique IDs for your database. So if you have inconsistent and changing budget codes, how you're going to map the whole time series and see how the trend has been. So those are the major 4 to 5 problems we have been facing. That's where Open Budget India comes. We are a platform to make India's budgets open, usable, and easy to comprehend. It's a community-driven initiative to focus on the open budget data. So from public accounts to trust in government, this is generally a cycle which has been followed across various geographies. Public accounts are where you can see the detailed information about how government is spending. And if they publish the budget data, and if it's in open format, you can then enable fiscal transparency using it. You can see where the priorities have been, what kind of tenders have been invested, where the money has been going across various departments and ministries. And eventually that can lead to trust in government. So for today's talk, we would be focusing on just the open budget data aspect of things. Let's see how things work. So open budget data is something which is publicly accessible. It's available online for everyone to use. It is in reusable format, not just giving the analysis, but giving the hardcore data points to the maximum disaggregated level possible, so that people can find their own trends, can do their own analysis. Without any restriction, it should be free. It should be legally open. So whenever you see that small C symbol in a circle, that should be missing from the government websites. No copyrights. Also, it should be machine readable. It should be editable online. It should be either in Excel or CSV to begin with. This is what we say open budget data should be, ideally. As per the Tim Berners-Lee, founder of World Wide Web, there are 5 stars of open data. The number 1 is PDF, which we get at the moment with most of the government websites. Second one is XLS, slightly open, but requires a vendor-driven software to use. Third one is CSV. Any machine, any digital machine can read this document and understand what is happening inside. Fourth one is RTF. That means you should have a web URL for your data set. And fifth one is linked open data. You are able to interact with these documents in a form of a graph. You are able to play around from one database to another database, link them together, draw your analysis. That is the 5th level of transparency. So that's where we want to take India's budget, to a linked open data. We are an open source community-driven initiative. All our code, design, algorithms, documentation, everything is available on GitHub. And we would dig in about the data pipeline today. This is how it looks like. Simple steps. Number one, scrape. Scrape the documents from various government websites in whatever format they are available. Some give us in Excels, like Sikkim and Union Budget website. Rest of them still give us messy PDFs. Second, parse them into clean machine-readable data to use. Transform them for making it more usable on a timely basis. Try to find the unique IDs, make it completely machine-readable, machine-consumable. Fourth one is publish. Publish it online, give a URL to each data set so that it could be used via API. And last one is analyze. The interesting part here is analyze comes after publish. So all the analysis should happen once we have already published this data. So you're not just restricting analysis in-house, you're kind of cultivating the open analysis of budget data. So let's focus on the scrape component today. There are around 150 such budget websites which give us information of several priorities of government. As you can see, each one follow a different template. That means each one has a different HTML structure. So we developed something like this, a utility, a centralized scheme of functions and methods which could be used for scraping. Call it scraping utils. Here you can download, you can download a file, you can do session management, you can do cookie management, you can do expat selection, so on. Then for each particular website, we write a very small plugin so that all the custom logic sits according to the website. So tomorrow, if the website structure changes, we would just change the plugin. This is relatively very small amount of code compared to the utility. At the end, we get the PDFs and Excels in whatever format they are available on the website. Just to give a brief about XPath, XPath helps to convert the HTML document or XML document in a tree structure. And then with the help of XPath, you can access a particular node or a set of nodes which follow a certain rule. Certain parent, certain child, so on. So this is an example to access edition language, German and French. And you can see the Wikimedia is the super parent, projects are further, and then project editions. These are the hierarchy. Second step is parse. So from 150 websites, we get 150 plus budget document structures. And that's another messy problem to solve. These are the kind of PDFs we get. So as you can see, there is slight tabular information there. As a human, we can see the lines, we can see the columns, we can see, okay, approximately these are the cells. But how to train a computer to do the same? That's the challenging problem. So what we have done, similar to the scrape pipeline, we have created a parsing pipeline. The centralized repository is PDF to CSV. We have most of our munging code, parsing code reside. Then individually, there are plugins to customize and tailor the content as per the state or union. So let's dig into the parse algorithm. What are the steps we follow? Step number one is loop over each page in the PDF and convert them into images. We convert each page of a particular PDF document into image. Sometimes these PDFs are rotated. So we unrotate them, we make them strengthen. And at the same time, we need to sometimes change the format. Sometimes these are A3 page. We need to convert them into A4 and so on. So these kind of page layout mechanisms happen in this stage. So we loop over all the pages. And for each page, what we do is try to identify a set of vertical and horizontal lines prominent in that particular image. This happens using hub transform. It's a very popular computer vision technique to detect line. What it does, you can see the demo there. It's like a lighthouse. It keeps checking for all the points available in the vicinity, uh, and then try to move into the direction where more number of points are present. So it's sort of a moving lighthouse. Step by step, you progress and you start drawing the line. So that rankings you can see on the right-hand side of the moving diagram there. So more the rankings in particular direction, that would be the way we would move forward to draw the line. Once we have drawn the lines, we try to detect the largest contour. So this happens using, again, OpenCV, a popular Python library for doing computer vision. We detect the biggest bounding box possible, the largest rectangular contour present, and that would give us the table boundary. Next, what we do is in this step, another thing is happening. We also extend the vertical lines to touch the table boundaries so that we ensure the whole table structure is in place. Next, we compute the coordinates for tables and columns for each page. We call it table attributes. These are top, left, bottom, right, and then the column coordinates extracted from step 2 as C1, C2, C3, C, and so on. This is then passed to a popular public library known as Tabula. It is very good at parsing PDFs, but it requires input from human. So what we are trying to do is give them the boundary boxes and give them the column coordinates. And what it does is detect the cells out of it. For each particular character in the PDF, we get something like this, the information of top, left, height, width, and rotation. So given a bounding box, we try to calculate the characters falling into that box. It internally uses Apache PDF Box, which is a popular Java library to parse PDFs to XML in this format. Apart from the common munging, we require some specific munging, which happens in the plugin, like fixing header values. Sometimes headers are inconsistent. Sometimes these rows and columns are merged or splitted because to make it print blindly. So what we do is either split them or merge them based on the logic to make it more machine readable. Filter out non-UTF characters because when you are pushing through API, it becomes a problem to deal with non-UTF-8 characters. And similarly, we do other data sanity checks to make sure the PDFs are converted well into CSVs, like total and gross, net, those kind of calculations. Finally, we get something like this out of it, which is much more easy to consume. But still, there are some problems with it. And that's what we would look into the transform step, third step. So for specifically state budgets, this is how the unique ID looks like. So these are the 7 heads you get. So demand number is department of that particular state government. Major head is function of that particular government. Sub-major head is subsector within that function. Minor head is a program with the subsector. Sub-minor head would be scheme, like Sarva Siksha Abhiyan, Swachh Bharat, so on. And detail heads would be like salary, official expenses, objects, so on. And in objects, we would have sub-schemes wherever possible. So these are the 7 heads, and demand number is the unique identifier for a particular demand. But this is what we get from the state budgets. This is Karnataka's budget. You can see here, you just get one code. So all information is hierarchical in nature. You can see urban health service allopathy being repeated multiple times. So you are trying to present hierarchical information in a flat structure, which is a pain to deal with. So what we do, we collect all this and bucket it with the help of a specific budget code. And once you have these budget code ready, this can act like a unique ID, and this is now finally ready to go into a table in your database. Next, we do publish. For publishing the datasets, we follow CCAN, and it's a platform which enables open data publishers to publish their data in a much more structured format. You can add detailed metadata. As you can see, you can have description. You can say what all formats are available for a particular data set. There are keywords, sources, tags available for each data set, which is really helpful for anyone who is trying to consume this data. This is how CCAN architectures look like. So at the base is a model. It's a typical MVC architecture. The base is a model, which deals with system database and a data store, which is mostly in Postgre. And on top of it, we have ORM model of SQL Alchemy and a search via Solr. And then sits the logic layer, it's the so-called controller, where authentications, actions, business logic, background tasks like updating the data sets, generating the site, XML, so on, happens. Views are generally rendered using Python's Jinja 2 template, which is a popular technique to publish HTML documents. And as you can see from logic, there is direct access to the API, where most of the information is given as JSON or multipart. And on top of it is simple routing algorithm, which routes your URL to a particular data set. On the left, you can see there is an opportunity to add custom plugins. Let's see what we can do with the help of plugins. So you can add libraries, custom libraries, JS libraries for visualizations, and other Python libraries if required. Your Python scripts for the controller, it uses pylons as the base architecture, so you can add your custom Python scripts. You can create your own Jinja templates. You can change the view, the hierarchy of documents completely. And you can add custom CSS, image files, and so on. And what you get for each extension is a simple functionality. For some, you can get visualizations. For others, you can get a sitemap, and so on. With the help of sitemap, you allow bots to index all this information. So none of the budget websites at the moment publish a sitemap. And that's a big problem for making it searchable. So what we do is generate a huge sitemap with detailed information so that these documents are searchable by users. And this is how the categorization look like. We categorize based on tiers of government, combined budget, union budget, state budget, municipal corporations. And in terms of sectors, we have chosen 12 developmental sectors like agriculture, education, drinking water, sanitation, and so on, so that specific researchers can look into the budgets directly. We also publish the datasets via API. This is how the API looks like. You can easily access the keys and then the approximate values for the same. And for each dataset, there is a resource ID, a unique ID to cater the information. All these datasets are under Creative Commons 4.0 CC BY license. You have to just use with attribution in your work. And how does the open link data comes into picture? So the unique ID which we discussed in a couple of slides back, 221001110, urban health services, allopathy hospitals, and dispensaries. With the help of Compler Auditor General, the 3 codes need to be unique across all the states. There is a mandate. So now, with help of this unique ID, you can query any state and try to link the whole information. So you can connect Karnataka budget for 2017-18 with previous years and compare it with Sikkim budget at the same time, just with the help of this unique ID. So that's the power of open link data. This kind of analysis earlier used to take months to do. But now with the help of this open link data, you're able to do this analysis just in 15 minutes or so. The last component of the data pipeline is analysis. This is how we analyze. You can see a time series of budget at a glance for union government, the central government, from 1994 to 2017-18. You can compare on the recovery of loans, total revenue, total expenditure of the government, and so on. And you can see how the trends have been. You can also compare the actual accounts, the estimates, the revised estimates, and so on. Also, you can analyze budget of a particular municipal corporation. You can see what is happening in your municipality. This is for Ahmedabad. You can see the trends and you can see the priorities of how your municipality has been performing in a couple of years. Also, with help of open link data, what we are able to do is produce analysis of union budget in less than 15 days. So as soon as the budget is out, you're able to create a dynamic tool where you can see the sectorial priorities of the government and of the budget, and you can then argue on the facts rather than just the opinions. So you get all the data in one single place available for you. Also, to extend our efforts, what we are trying to do at the moment is have an aggregated comparison of state budgets. You can see which state has been investing more on which sector. Again, the same 12 sectors. You can see how in agriculture, Karnataka is doing as compared to Tamil Nadu, Madhya Pradesh, Himachal Pradesh, and so on. And you can see not just the total expenditure, but also the total sector expenditure as percentage of state budget. You can do per capita expenditure. Per capita is per the population of that particular state. So you can see drastically the figures change. Maybe the total expenditure is huge, but when it's compared to the population of the state, expenditure goes down drastically. Now, also you can see the revenue expenditure and the capital expenditure. Revenue expenditure is something which is an ongoing cost, while capital expenditure is something like recovery of loans or buying of land and so on. Also, one more motive of our initiative is to educate people. Currently, it's very difficult to understand what is happening in the budgets, what are these codes. Demystification is very key, important aspect of open data. So what we are trying to do is create something known as budget basics, where you can get a very detailed information of how budgets function, where is the money coming from, where does the money go, and so on. Future work, what we want to do with these budget codes in place, we want to create a public national database of budgets covering all the levels of governments, union budget, state budget, municipalities, and eventually district treasuries as well. This would help us to compare with the help of unique ID what is happening in each government body. And we can see the time series of the same. So suppose I'm not aware of what is the budget code for hospitals. What I can simply do here is type in hospital, and I would see all the data coming in. So the index is not just on the code, index is also on the description. And this would also facilitate fuzzy search. For example, Karnataka writes Sarvana Sikshana Abhiyana, while Madhya Pradesh writes it as Sarva Siksha Abhiyan. So while you type either of these, you should get both the results. So fuzzy search would be also in place. So this is where we have been heading so far. How you can contribute? Help us generate more open data in budgets. We are struggling in scaling up since the number of departments is huge. So help us evolve our algorithms, contribute your ideas, suggestions on what else we can do. Evolve our code base. Everything is in public domain. Everything is on GitHub. So give your suggestions, open some issues, help us find some bugs. That would be really helpful. Cover budget data in your geography. Currently, there are only 98 municipal corporations publishing their data out of more than 300 municipal corporations. So help us cover more municipal corporations on the portal and help us convert those PDFs into clean CSVs. Refine our designs and help us do more analysis in time. Help us with more suggestions on how we can make this data searchable and usable. We are open to new ideas, suggestions, and feedback. Here you can reach us. These are the slide URLs, the code URL, my email address, and all our Twitter handles. Yep, that's it.
We will take only a couple of questions as Gaurav and the next speaker Rakesh will be available for the OTR session. So just, yeah, there.
I think OTR is at 3 p.m. in the room 1. Yeah.
Hi, this is Paridhi from American Express. And thank you so much for the presentation. This is one of a kind that I've seen so far. One quick question that I have is that this is one use case which is for the budgets.
Yeah.
But if I want to export this technology, this complete architecture to banks, for example, I want to know what my rival banks are performing, I mean, over the period of time based on financial audits. So how well do you think this technology can be ported and how fast can it run?
Sure. So each component of this pipeline is open source. So you can just start picking the scraping utils from here. You can pick the PDF to CSV from here if you're dealing with PDFs. You can see the transform code from here. And already the published platform is an open source. Analysis is something which I think would be very custom tailored to your use case. But the first 4 key components are already in public domain. You can start picking and playing around with it. Depending on how complex is the structure of your data, that would govern the time it would take to replicate this pipeline for your use case. The processing or the development of the pipeline? Development of pipeline took us almost 1.5 years. But now it's an open source, so the replication would take hardly few weeks. That's what we estimate.
Okay. Next question. This side.
This is a great initiative. This will make data available for all of our citizens.
Put your mic a little closer. Hello.
Yeah. But I wanted to ask you, are there any initiatives, not related to this, but any initiatives to help governments generate data in a systematic way? Rather than them generating data in PDFs and we going through this complex pipeline, you give a tool to a municipality, you give a tool to a central government or a state government where they key in this data in a tabular format. It will generate the PDF as well as this CSV. I mean, something like that.
So I think Rakesh would be covering in detail about that part, but I would just give my few points there. I think it's currently difficult to convince government to use an open source technology and give open data by default. So that's where the struggle has been. Most of these departments are using treasury softwares, but all of these softwares are proprietary in nature and suffer from vendor lock-in. So those are the major problems. We do have a policy in place, National Data Open Sharing Policy, but very few data sets are out in public.
One last question.
Hi. Does CScan store data in RDF format?
Yeah, so URL one is actually RDF format. So you can access it via API.
Okay. And what is the number of triples that you have?
Number of?
Triples?
Can you explain that?
Like that's each entry, subject, predicate, object that you have. So what is the total number of
I think it
records?
depends on the structure of the document. Some have more, some have less. But on an average, we deal with at least 15 per row, 15 per object. Performance so far of the platform or the parsing part? Platform so far, we are able to serve more than 10,000 requests per hour. Yeah.
Yeah. Thanks, Gaurav. Gaurav will be taking more questions at the room 1 at 2:05 p.m. We have an OTR session which has Gaurav and Rakesh, so you can discuss this there. Thanks, Gaurav.
Or you can tweet me here. I'm available here as well.
Coming next up is Rakesh Dubudu of Factly. He's going to talk about open data in government and the challenges around it.
discuss one specific case of Telangana Open Data Initiative.
Sorry. In the process, we also help governments opening up data. So currently, we're working with the government of Telangana. Uh, so I thought I'll talk about, in general, the challenges in opening up data and our experience with, the government of Telangana. So this is from the preamble of the Right to Information Act. So I'm sure most of you know Right to Information Act that was passed in the year 2005, hailed as one of the best legislation this country has ever seen. This is from the preamble. So most of what we are talking about in open data or information from the government actually flows from this preamble. So it talks about, we need to have an informed citizenry, and informed citizenry is not possible without government supplying information. And informed citizenry in the process will help in, controlling corruption and ensuring that all the government, instrumentalities in terms of bureaucracy, the political system is accountable. Now, so there is a specific provision in the Right to Information Act, which is called Section 4, which actually talks about proactive disclosure from the government. So right now, if you, people with experience in dealing right to information applications would know that it is mostly demand-based. So you make an application, government will supply whatever information. But there is also a supply-based provision in the Act, which a lot of people do not know, which is Section 4. Section 4 actually talks about proactive disclosure from the government. Of about 17 items, which actually covers budgets as well. So when we talk about open data actually flows from Section 4, where governments, without people asking for it, should actually disclose. Now, we say it shouldn't be that data is available, but people cannot access it. So after the advent of right to information, it's close to 12 years now. So I can show you the transformation. So this is pre-2005, municipal medical records in a government hospital to a collectorate in Nalgonda. Now, this took a long time, of course 12 years, and I'm not trying to say that this is the situation in every office. It has changed, but unfortunately, this hasn't helped us go here. So we still deal with, like Gaurav was saying, PDFs, unstructured data, even when you use RTI, people give you physical formats. So while information is now open, people are able to access information, it's still, quote unquote, not machine readable and in the form that we want. So ideally, we want governments to open up data. In the sense, every government, like, one of them was saying that they publish in a structured format that people can readily use. So briefly, let's talk about the government structure. I think that will clarify a lot of things, that questions people have. So, let us not be under the assumption that the government is a monolith. Government is not a monolith. So each government department is their own boss. So at the central government level, there is this ministry called the Ministry of Statistics and Program Implementation, which usually generates a lot of data, especially for policy framing. So they have 3 different wings. One is the National Sample Survey Office. You might have heard about national sample surveys. So these are surveys done on a certain sample size covering all the states. So every once in a while. So they don't take 10 years like the census. They're done, so some of them done twice every 5 years, some of them once every 10 years, and so on and so forth. Then there is the Central Statistical Office, which calculates our GDP. So you must have heard about this office recently because of the whole, that fiasco about is the government fudging GDP data, etc. So the chief statistician comes from here. So they publish GDP data, they publish inflation data, and all that. The third one is a program implementation wing within the MOSPI. So this actually monitors a lot of big infrastructure projects. It's called IFMD. They also have something called as IFMD, Infrastructure Management Division. So they regularly monitor all the big infra projects. Now within this, they also have, MOSPI Government of India has come up with a guideline some time ago where they said any big project of Government of India or any scheme for that matter, which has an outlay of more than 150 crores, will have to be monitored and will have to have an online system so that people can, government can track it. So which is why you see a lot of schemes with a huge outlay of hundreds of crores usually have a working MIS. Yeah. So this is at the central government level. Now is this the only department that generates data? No. This is one of the departments, but their only job is generation of data. But on the other side, you have every department, every ministry at the Government of India level generating data, like, for example, the Ministry of Finance generating budget data year after year. The Ministry of Health generating some other health survey data. So it is not as if there is a unified vision of data generation where we say, every government entity will generate data in a specified format. So that's one issue. At the state government level, we have Department of Planning. At the state level, each state has a Department of Planning. So this acts like MOSPI at the state level. So we have state level data of economic surveys that are released during budget time. So within the Department of Planning, we have the Directorate of Economics and Statistics. So they release annual reports of states every year if you follow annual reports. So this is more like a statistical snapshot of the state. So every year they release this report. Now, most NSS surveys also have state component in it, in the sense they also release data of the state level, what is happening at the state level. Like I said, all other line departments also generate a lot of data for their own need and purpose. And there are independent agencies which, quote unquote, or within the control of the government, they also generate data based on the need. So I'm sure the problem is pretty clear now. So it's not as if there is one standard, one agency mandating the data should be generated in a certain way. So part of the problem is this. So even, for example, even a village panchayat, the lowest tier of governance, also generates data for their own need. Now, briefly about the National Sample Survey. So the NSS does surveys on varied subjects, broadly 4 subjects. The first one is socioeconomic. So this includes savings survey and spending survey, and travel pattern survey, and various other things. So if you go to the MOSPI website, you'll find all these interesting surveys. They also do a 5-year survey on, every 5 years they do this survey on land holding, livestock, and agriculture. So, you'll find what is the average land holding in India, how many are small farmers, how many are marginal farmers, how many are, large farmers. Same with livestock. They also have a livestock census that goes with normal census of human beings, and the agricultural census. They also do surveys on establishment and enterprise. So number of establishments, in each sector, number of employees, number of labor. Then village surveys. They also do a lot of village level surveys to understand village issues. So broadly, these are the subjects under which MOSPI, the National Sample Survey Office, works. So like I said, how is data generated in the first place? So firstly, a lot of data even today, especially in the large schemes, is still manually entered. Now there are multiple issues here. Well, I'll tell you a case study of the NREGS. So we have, for example, for most government schemes, which, for example, the NREGS, the key is the muster roll. So muster roll is more like a sheet in which the names of people who attended that day's work is written and with their signature. So muster roll is proof that you attended that day's work and you are entitled to a certain amount of, that day's labor. So we still, a lot of data at the grassroots level is still generated in physical forms and then manually entered. So you can see there is scope for error there. Then we have some automated applications where, especially with respect to wherever we do GIS tagging, so they do use automated applications. And there are various registers which are later converted into, the physical data is converted into machine readable form. So these days, for example, at least in Telangana, one of the departments has been using WhatsApp extensively to collect data. So from school, so all the school headmasters would WhatsApp data in a specified format for 5, 6 parameters, and then this goes to the central office where it is converted into an Excel. Then finally this Excel is, so there are varied formats in which data is collated and generated. And like I said, automated, so especially with transaction data, so wherever government is involved in transactions, so that data is automated. I'll briefly explain about the flow of the NREGS. I'm sure all of you know the National Rural Employment Guarantee Scheme, which was introduced in the year 2005 after the UPA came to power. So this was their flagship project. So it talks about providing wage employment to all the rural people. So it doesn't differentiate between a rich man and a poor man. So any individual living in a rural area is entitled to get work. Now, though this is probably one scheme with the largest outlay in this country. So in the last 10 years, the outlay has been more than 3 lakh crores across the country. So if you look at this, the first one is registration of the worker. This happens physically. So at the Gram Panchayat office, there is a form that one needs to fill saying, I want to get enrolled as a worker. So you'll have to submit a few proofs. That is the first step. And after this is done, this is actually entered into the system. So PE talks about post-event. So it's not real-time entry into the system. But once those physical forms are filled, bunch of them go to, usually what happens is, again, I'm speaking from a Telangana experience, it could be different in different states. Usually the block office has a dedicated place where about 5 to 10 systems would be there with internet connection. And all people from the village collect these physical forms, go to the block office, they reserve some time and then do this entry. So most offices at the block level use that dedicated space for online entry. So then you have issuance of the job card. So once you apply for work, so if the form is proper, then you're issued a job card. Again, this is physical. Then demand for work. So the scheme is a demand-based scheme. It's not supply-based scheme. So in other words, I as a worker can go and demand for work, saying, I don't have any other work elsewhere, so I want to work. So the demand is captured. This also, in some states, it's happening real time, not in all states. Then work allocation. So how it works is, there is a shelf of works decided by the Gram Panchayat. So there is a list of works. And ideally, the Gram Panchayat should decide that work should be taken up as priority. So a lot of criteria involved. So then work allocation happens. Then e-muster, of course, like I said, e-muster is not there in all states. Some states are doing it. E-muster is like the electronic muster. So once work happens, you capture the attendance, then the muster is generated where it has names of workers along with the amount that they should be paid. And then if you see the entire flow, so the daily attendance, preparation of MBMB is measurement book. So once the work is done, there is a technical engineer who comes in, measures the work done. And based on the measurement, there's something known as schedule of rate, SOR. So based on the schedule of rate, based on the amount of work done, a particular wage rate is decided. So it could be 100, 150, 170, and that is transferred to the wage seeker's bank account. Then the preparation of wage list, wage slip. FTO is nothing but a transfer order. So financial transfer order, which talks about money actually going to the wage seeker's account. So this is the entire flow. Now, as you know, it is actually very, very complex. And we're only talking about one scheme of the government of India, which, in terms of budgetary figures, it's less than 5% of government's budget at an overall level. So you can imagine the complexity we are dealing with. So to tell you the formats, so these are the physical formats. So job card, application for job card. So somebody has to apply in this format. An application for work. Of course, these are translated into local languages. They're not available in English. Then this is how the muster roll looks like. The physical muster roll, then transformed into the electronic muster roll. And this is how it happens on the ground. So this is the work site. This is the engineer measuring, and again the engineer measuring. So this is the work, road laying work. This is, for example, building a tank, water tank. So you can imagine the complexity. So this is a snapshot from the NREG-MI. So this is one scheme, like I said, with schemes with a huge outlay, we have a working MIS. So if you go to nrega.nic.in, so all this data that I explained to you before is available on that MIS, the snapshot from that MIS. So you can actually go up to the worker level, wage seeker level, to understand what kind of works did he do in the last so many years, what was the amount of money that was given to him in the last so many years, the kind of works done at a block level, at a village level. So what is the ratio between material and men? So all that. Now, just to understand the complexity of this data, like I told you, the expenditure in the last 10 years has been close more than 3 lakh crore. Then how many percentage of work was generated? 1980 crore percentage, which is 18 times of population. Then there are 25 crore wage seekers, not active, but people who are enrolled into this scheme till date. Then there are about more than 12 crore works that were done on the ground. And on an average, every day, about 50 lakh percentage of work is generated. So in other words, ballpark average, about 50 lakh people get work from government. So this is the complexity we're dealing with. Now, what is the status of data generation, data disclosure in the government? Like I said, for major schemes, we do have MIS at various levels. There's a central government MIS, there will be a state government MIS. So the data will be available in some structured format. So pensions, PDS. So all the schemes with huge outlay, you have these. Then for smaller schemes, we have data that is maintained at local systems. So we don't have it on the internet, so it should be on the computer of some clerk or some officer. So it will be in his system. So there could be schemes with an outlay of 5 crore, 6 crore. They don't have an MIS, but still 5 crore, 6 crore is not a small amount. So they are maintained at a local level. And then still, for example, village budgets. So though we have Panchayat Raj Ministry software to capture village budget, it's still not. So a lot of villages still follow the manual paper budgeting procedure. So let me spend some time in talking about this. Now, a lot of people think technology is the issue, in the sense, the issue in opening up government data is technology. No, that's not the case. The bigger issue in opening up government data is trying to change their culture. So they have a culture of secrecy, just gone on for close to 60 years now. And the same kind of resistance we see even in right to information. So when somebody applies under RTI, getting information, I know if somebody has applied, you will know the pain. So the first thing that anybody has to deal with is the culture. How do we make them understand that you are part of the changing culture, it's no more secret. A lot of government officials derive their power from holding this information. So it is very, very difficult to part with this information. So they feel that everybody then will become powerful. Their power is taken away. So culture is a huge issue. So while we might discount saying, why can't the government just mandate everybody to do, it's not as easy. The second one is fear. There's a lot of fear within the government bureaucracy about misuse of data. So for example, this also partly comes from their own understanding of technology, because there was an official who was telling me, if I put an Excel on the internet, can somebody not download the Excel, change it and upload it back? So this was his fear, that somebody would actually change the data. So this partly came from his own lack of understanding of technology, and partly from, because at the end of the day, they have rules that are very strict, and anything that happens with data, they are liable. So these are two big challenges. Wherever you go, if you talk to government officials at various levels, these are two big fears. The third one is lack of capacity. Frankly speaking, does our government have the capacity to handle data at this scale? Frankly, no. So how are they able to manage today? So each department has their own vendor. So yes, government has a technology wing called the National Informatics Center, but not every state government or every scheme is handled by them. So I'll tell you an example. Health department, for example, in Telangana has 8 different modules, and each one is developed by a different vendor. So partly one reason, because they don't have that big picture understanding, they tend to do temporary work. So I have a need today, I need a solution today, let me develop something. But how does it actually connect to what is already there? How does it connect in the long term? People don't understand. So these are, I think, 4 big reasons, challenges in opening up data. So while there is a lot of work on the technology front, I believe in India especially, we are not working enough on the first 2. On changing the culture, trying to tell them that it's a changed world, it's no more 1950s, 60s. So we are facing the same issues with right to information as well. So when people ask that culture of sharing information. Then So I'll briefly tell you about the Telangana Open Data Initiative, what we're trying to do. Small video. Yeah, I hope you all understand. I'll move to the next slide. So what we're trying to do with the Telangana Open Data Policy is actually addressing the first two. While we are also addressing technology, not that we are discounting technology. So the government does not believe in going belligerent and opening up, all data sets, but wants to take it in a phase-wise manner where we talk to officials, explain it to them that, why sharing is important. How can we change their own internal culture of data sharing? Then we're also focusing on, like I said, the challenges. So we intend to hold regular community events. I'll also tell you an example. So I'm not sure how many of you know, Telangana government has reorganized its districts. So the earlier 10 districts are now 31. So even, for example, Google does not have maps today of those 31. So the government will soon release. They're finalizing boundaries. So we already have a dedicated data portal. It's called data.telangana.gov.in. There are very few data sets, but the intention is to make this more active. So these are the new districts. The shape files are getting ready, as in the boundaries are getting finalized. So very soon the government will release them. So one more case study and we'll probably end it. So Bhumi is the comprehensive land records portal of the government of Telangana. So it has land records up to a village level, so up to the individual beneficiary level. So it's in each state it's called by a different name. In Telangana it's called Pahani, village Pahani. Pahani is nothing but a register that contains the land records. Now for each land ownership record, there are more than 10 parameters that are there in this MIS. For example, if this is a screenshot, it's in Telugu, so it talks about the total extent, how much is cultivable, how much is not cultivable, what is the source of water for that particular land ownership, who is the owner, then various other things like that. So what kind of land is it? Is it dry land, wet land, various other stuff. So what can be done with this? So we had a community event where a few students developed this. So we wanted to develop a village dashboard. So at a village level, can we, this is one data set, the agriculture data set. So can we, in the same way, can we source more data sets and then prepare a village level dashboard for planning? So for example, this comes from the Bhumi website, as an example. What we had done was to understand the land ownership in that village. So what is the total ownership, average ownership, how many small farmers, big farmers. So how much of the land is actually cultivable. So what kind of sources does that village have, etc. So going forward, the idea is, take such case studies, take such data sets and involve community in developing various solutions. So probably I'll discuss this in the OTR session. We don't have enough time. So what do we expect from the community? Like I said, the government intends to hold regular events. I will keep informing you. So please participate in them. Then please provide suggestions or requests for data sets. Like I said, the data that you want may not be available, but if it's available, we'll try and push departments. Please come up with solutions. So a lot of problems to be solved. So government is open. If you have an idea that can actually solve a real problem, please come forward. And if you have any ideas, please write to that email ID, opendata@telangana.gov. Thank you.
We can have a few questions. Question this side.
So there is a already existing portal of opendata.gov.in. So how different is your approach towards that from the data set?
Yeah.
I see a lot of data being uploaded there and that's still available public.
Yeah. Data.gov.in, like is the Government of India portal. And Government of India usually has aggregated data of states. So the data comes from central government departments. As you know, the real, if you want to call the useful data, would be hyperlocal data, not the aggregated data. So usually the central government does not hold hyperlocal data, it is with the state governments. So what the data portal of Telangana intends to do is provide that hyperlocal data. So aggregated data, we are not trying to reinvent the wheel, so which is already available in data.gov.in. It will probably the data set will also be available here, but the idea is not that. So true.
Hi. First of all, this is regarding the rural employment scheme. This is regarding the rural employment scheme. So, is there an insurance for these people? Say, who
Is that?
Is there an insurance for these people who are working?
No, there is no insurance.
There's no insurance because
there is an accident claim, accident compensation, but there is no insurance. There's a compensation given if something happens to you while you're on work.
But that is only for the BPL, right?
That's
only for the BPL, right? Below poverty line.
No, the Rural Employment Guarantee Scheme does not differentiate BPL, APL. So it's anybody living in a rural area. If you want work, you can demand work from government.
So work is different from insurance.
Yeah.
So work is different from insurance, right? So because APL and BPL both work, but what I read recent times is like it's only the insurance is only covered, or accidental insurance is only covered for the BPL and not for APL.
No, there's, see, like I said, as far as I know, I could be wrong, but there is compensation for accidents on site. There's no insurance as such.
More questions?
So you've developed this whole model for Telangana, which we know is like a new state. So you can have all the latest technologies and the latest trends implemented in it. Now, once you've developed this model, how modular is it that other states can adapt it? Like, how have you taken that thought into consideration?
Yeah, though Telangana is a new state, it has a legacy of the last 60 years. So the new state is only in the name. So the state still has all the ills that you see in a typical bureaucracy. So in that way, the state is not different, but the leadership is very open in terms of changing. Now, when we say modules, see, I'm actually not talking more about technology. So for example, the data portal of the state is actually developed in an open source platform called DCAN, so which is another version of CCAN. What we are intending to do is build a model by which, where we force changes in the culture and not just give them a technology, mandate something, and then make them give data sets today, and tomorrow when you and I are not there, data set doesn't come. So that is precisely what is happening with data.gov today at the government level. So it is not a legislation, so we have to understand. So this is still a policy where we ask government departments, request them to open up data. So in terms of our priorities, so once the state is successful in opening up a lot of data and actually solving problems, it being useful to various stakeholders, the idea is to document all this and share it with whoever wants to. It will be available on the website as well.
One last question.
Yeah, I want to ask, like you talked about different kind of data you collect, that is socio-economic land holding. I'm curious to know, like, is there any geospatial kind of data like which you collect, and like addresses or bus stops?
See, again, it varies from department to department. So for example, if bus stops have to be captured, it is a municipal corporation that has to do it. So there is no agency. Yes, there is an agency that deals with geospatial in every government. So we have something known as TS track, but their mandate is not to geotag everything. So their mandate is to prepare maps and boundaries. So it is a department's priority. So if bus stops have to be mapped, the local municipal corporation has to do it. So there is no, I wouldn't say the geospatial data is being generated at a large scale today, but there is an effort in certain departments to do it. So most of the, for example, the NRGA works are now geotagged. Most NRGA works are now geotagged in terms of where was the work done, what kind of work. And in large schemes, it is happening definitely. But in smaller schemes and smaller departments, it's not yet done. Which data? Which is what I'm telling you. So right now, the data portal of Telangana is very, very nascent. So you won't have a lot of data sets, very, very basic data sets, the baseline data sets. So in the days to come, we intend to do that. Not right now, but yeah, in future. Probably in 6 to 12 months, you'll see some progress there.
Thanks, Rakesh. That was a great talk. And people who have more questions can catch Rakesh and Gaurav at the OTR session, which starts at 2:05 p.m. in room 1. It would be about using open data in different scenarios and the challenges and opportunities around it. We break now for lunch, which will last for 1 hour. We'll resume sharp at 2:05 p.m. in the same hall. We have some limited dinner tickets available, the conference dinner with the speakers. The cost of ticket is 3,000. It includes the dinner and networking. You can buy the dinner ticket online or at the token counter outside, and it's at the Blue O Bowling Center in the Whitefield, which mall? Phoenix Market City Mall, right. And also we are inviting proposals for flash talks, which would be from 5:10 p.m. to 5:40 p.m. today. The flash talks need to be strictly of 5-minute duration, and you can talk about anything, open source project you've worked on, some tips and tricks, some experiences you've had. And to submit this flash talk proposal, you need to write it on a piece of paper, the topic, or a postcard or something, and submit it to me or any of the 3 volunteers sitting in the front row right side. And that's it. You can go for lunch now. Nice.
Check. Check, check. Is it audible? Let's have it here. Get it started? So hi, good afternoon everyone. So I'm Ram Prakash. So
people please settle down. We've started with the talk.
I'm Ram Prakash. I hope I make this post-lunch talk interesting. Yes. So not audible. Better now? Is it better now? Hello. Check. Right. So this is my Twitter alias, and I work for this company called Zoho. So we make lots of business and productivity applications. We call ourselves the operating system of business. And I work for a particular group called Zoho Labs, where we design solutions to our product teams, and we kind of offer it as a service to them. So we work on lots of interesting problems like hardware acceleration using FPGAs, GPUs. We are one of the active contributors to PGSQL, and we have a division that works on machine learning and artificial intelligence. So I own the machine learning product stack there. So I hope that gives you a good idea about me. I'll get into the talk. Now let us look at the problem description. Right? So ML as such, machine learning and artificial intelligence is very snake coil-ish. I know that term is a bit difficult to digest, but it is more of, there are no proper proven results of an ML system autonomously taking decisions. There always has to be a human element which can get in and make the decisions for you. So any ML practitioner would accept with me that this particular field hasn't matured enough for a full-blown business production system. Right? And coming from the B2B world, there's not much differentiation you as an ML service provider can offer, because almost all the algorithms are open. And in the B2C world, you have this data advantage, which means, hey, I know better than you than the other company, so my algorithms would work better for you. But that is not the case with B2B companies, and that is not the case in highly regulated industries where data is well defined in a schema, and if it is a CRM system, you're only going to get contact leads. If it is a support desk system, you're only going to get support tickets. So there's not much differentiation you can offer apart from your competitor. Right? And we all use cross-validation techniques to evaluate your ML models, which I don't find it very convincing for a production system. Yes, it's a good indicator, but that might not be the best indicator of the accuracy of your ML systems. So problems like these could happen. So one is data leakage, where an unintended variable in your training data set has an unintended effect on your result. For example, let's say a patient ID is heavily correlated to the chance of that patient getting a cancer or something. So this is unintended data leakage, and your cross-validation systems might not be able to capture such edge cases. And there could also be a data set shift, meaning it is the standard practice in the ML industry to take a snapshot of data from the past, train a model over it, and then pass on other snapshots of data from the near future, make validations on that, and get the results. But real-life data keeps changing, and in B2B companies, you could be actually deploying one particular model and serving it to many customers. So you'll have to make sure all your customers get their predictions right, and you'll have to tune your models accordingly. So these are all certain problems which we face, and there comes a solution called model explainer. So what if your model can explain its prediction? So it basically happens in real life, right? So you ask someone to do it, they won't do it. But you ask someone to do it and tell them, hey, this is why you have to do this, and there is many a chance that that guy is going to do that. So this is where we took our inspirations from. This paper was like, it took the industry by storm. There were lots of interests around this paper, and the interest hasn't faded out yet. So we started looking at this paper, and so this is what this paper is all about: local, interpretable, model agnostic explanations. I'll break that down into simple sentences for you. So this is where we have our own, we have hosted our own version of it. We made it production ready. It is Apache 2 licensed, so it is commercial friendly licensed. And so we had to do lots of changes so that we can serve this explainer in a real-time production system. So for which the existing implementation from the actual paper was a bit difficult, and we are primarily a Java-based company. So we wanted that to be on Spark. We use Spark for our machine learning implementation. So we thought it is better if we could write it on top of Spark. So that's it. So coming to local and interpretable. So the explanation you give has to be local to the given query. I know I have an example coming up for that, and that explanation has to be interpretable for an end user to understand, right? And this is one change which we are making so that we make it suitable for production. So model agnostic is the actual paper is model agnostic, meaning you have an explanation system which works independent of the underlying machine learning model with it. It looks at the parent data set and it gives you an explanation. But we have got certain clues from the model, so we have made it, it is not model agnostic now. So the one-liner of this particular framework is, your model can be complex and nonlinear. So we are trying to fit a simple linear model around your query so that your explanations are interpretable and local. So I know I haven't given you the right example for local, so this is the case. So the ML world's very famous example, the housing price example. So now you have lots of variables like you're going to buy a house somewhere in Bangalore or somewhere in Chennai. So you have variables like size in square feet. Is it an apartment? Is it a luxury villa? How far is it from the nearest landmark and all that? So a global explanation would say particular result is because of the size in square feet. So that would have the highest correlation with your end result, right? But look at the second case. You're buying a 600 square feet luxury villa. Here you cannot go and get your explanation saying, hey, this is priced greater than 1 crore because it is a 600 square feet house. That reason doesn't hold good, because for this particular query, you'll have to use a different variable. So here, the explanation could be, it is a luxury villa, so it is priced that way. For the first case, it is a 1,800 square feet apartment, so it is priced this way. So I've explained the same in a visual way. So these are certain features: size in square feet, distance is luxury S, and there are 3 categories: less than 50 lakhs, 50 lakhs to 1 crore, and greater than 1 crore. Right? So you get the context for locally interpretable, right? So this is what it is all about. So, and importantly, the local faithfulness does not imply a global faithfulness. So there are 2 different ways to explain models. One is giving you a global picture. Second is giving you a local picture around a given query. So here, the problem we are trying to solve is a local picture. A global picture, there are lots of ways to do it. It could be as well as, getting the feature weights from your decision tree and just printing it out, or visualizing your data set. That can give you global solutions. But local solutions are a bit a different ball game. So that's what we are trying to solve. So I'll just explain you the design of the system. So this is your actual, this is how we lost the model agnostic feature. So basically, for each and every query, we had to look up the training data so that the model is model agnostic. The explanation model is model agnostic. So we made a tweak saying, okay, we'll borrow some data from the model itself, and then we'll use it. So that was one major change which we did. So we lost the model agnostic property, but we have still kept this open. We could always, switch it so that tomorrow, in case a model agnostic need arises, then we could always roll it back and get it out of there. So this is how it is. So there is raw data coming in. That is the training data you give it to train your machine learning model. And we look at the continuous and categorical columns. So for now, we are only looking at tabular data sets. We are not ventured into text and images so far, but that is definitely in the pipeline. So we look at the categorical columns, we sample them, and we look at the continuous columns. We divide them into discrete buckets so that you kind of reduce your dimensions, and we inject that into the model. Right? So this is your training process. So as and when you create your machine learning model, then you can do this. Now this happens during a query time. So you have a given machine learning model, and you have a prediction query that is coming in. You're going to predict it on the model and give it. So now you have a binary vector. So this place is where it could open up for the future use cases. So the binary vector here, in the case of a categorical or a continuous feature, it is a mere presence or absence of that particular variable. Right? So in other cases, let's say tomorrow you're trying to explain images with that. It could be patches of images. So it could be a continuous group of images. Let's say tomorrow you're trying to do text analysis with that. It could be a continuous set of words that could be given for the explanation. So there's a binary vector which determines the presence or absence of that. And we do some scaling on that. And based on that discretized values, we get the sample weights. So now we get the weighted data. And we have a feature selector and a regressor so that we could get out the features and give them a score, getting a confidence, right? So we started off as this to primarily trying to test our own algorithms and configurations. So the thing is, like, we in Zoho Labs, we try to serve other product teams. So we'll have to give them a compelling value add first to the product managers of other product teams, and then to the users of the other product teams. I mean, users of the other products. So there has to be a compelling value add, and this seems to be a, like it is without any dependence of the other product team, so we can get this started on our own, and the value add would be exponential with this case. So we started doing our pilot in our churn prediction app. So like every org has, we have a churn predictor which looks at the access logs and tries to create a model on which if a particular subscriber would renew his subscription or would he churn. So we have variables coming in from the access logs, we have variables coming in from the help desk, number of tickets interacted, sentiment of the tickets, number of tickets escalated, and all that. So we have so many variables that come into this churn prediction system. So we thought we'll hook on this explanation engine to this churn prediction system. So these are the results we were getting. So this is for a user who is going to renew his subscription. So it says, hey, he has done lots of bulk insert activities. So this is for a campaigns product. It's called Zoho Campaigns. So this data is a snapshot of that. He has sent more number, based on the campaigns sent, there is so much of probability that he will buy. And based on the percentage of non-HTTP 200 requests, there is a probability that he's going to renew. Right? So these are the explanations for this particular case. And this is an explanation for a guy who's going to leave. So this guy has a more probability of leaving because of the value of his percentage of non-HTTP 200 requests and too many support tickets and active sessions. So we would also be able to print out the value, but I'm just giving you a visualization here. So we are trying to roll this out to customer-facing apps in a phased manner because mostly in the B2B world, people turn off automatic recommendations. People want to do it themselves. So we have started rolling out this to customer-facing apps in the form of a notification. Hey, this could be because of this. So that we instill trust on the user and we get him to use more of the machine learning features we have in the pipeline. That is the whole goal of the project. I thought I'll add the slide for, so these are the other ways you can actually get in and try explaining your models. So a quantile regression is where you take it percentage by percentage. I haven't explored all of these, but these are the other things that are available in the market which you can go back and start looking at it. Glyphs and correlation graphs are visual representations of your original data set. So we had used a lasso regressor there. So there is one with least squares regression and there is one with elastic net regression. So basically you try to calculate the feature importance given to that particular query based on some assimilated data. And there are tools like GAMs which can allow you to hit a sweet spot between complexity, accuracy of the model and the explainability of that model. So you can get in and you can tune it to see how things are working. And then there are dimensionality reduction techniques like TSNA, autoencoder networks, PCA and all that. So which could project your data set into a lower dimensional space so that it will be easy for you to visualize and understand. So these are other techniques which you can go back and have a look at it. So that's it for me. And just to summarize, so we are trying to build a predictor. We are trying to build an explainer that would explain predictions of a machine learning system. This particular explanation is mostly for a local query. So a query that is, with respect to each and every individual query. And this will instill trust on the end users. So we are trying to roll it out in phases. We have a GitHub page. So we have hosted it on Git with an Apache 2 license. So your contributions welcome and please feedbacks welcome. Right? Yeah.
Thank you. We have questions. We'll start from there.
So hi. So thanks for this. So you mentioned that the model is local and interpretable, right? So, but in the last slide you show for the churn customers. So this is the functionality. So, but it should be for individual churn customers, right? As in, like, if it is local.
Yeah. These are just snapshots like for individual cases. So here you look at the number of variables in the system. It is the same. So for this particular result, it has chosen 3 variables, which is bulk insert, campaign sent, and percentage of non-HTTP 200 requests. For this particular query, it has chosen 2 different variables and percentage of non-HTTP 200 requests.
Okay, so is this for a single user or the group of
these are 2 different users. So one is a guy who is going to buy, who's going to renew. One is a guy who's going to leave.
Okay. So then it's not local, right?
Sorry?
It's not local, right? It's the global phenomenon for the churning group and the non-churning group.
No, it's not for a group. It's for that particular individual user.
Okay, question here.
This might be a very stupid question, so sorry for my ignorance, but it looked like your binary, this thing, vector and all, looks like a bunch of nested if else to me. I mean,
sorry, I'm not able to.
I mean, your binary vector thing and all, this thing looks like a rule engine with a bunch of nested if else. Where is the model? I mean,
I'm not able to get his question.
I think what he's trying to say is that he saw a lot of if else there. Am I correct?
model thing you're talking about seems to me depend a lot on your ability to parameterize and look at with a sample size of 1. Like all the example was on a sample size of 1. So I think you're making a rule-based engine here with a lot of if-else thrown into it,
actually,
nested if-else.
So
where the machine thing comes in?
We're trying to fit a simple linear model around a very complex system. So that is where, so for linear models, explanation is very simple. So it holds good for a decision tree. So we are trying to build a simple linear model around that particular query. So that is the whole crux. It is okay. When we make it model agnostic, it is totally independent of the underlying model. Meaning your model can say this guy will churn, but this guy can come in and give an explanation for this guy will subscribe. So that is now that we are borrowing some data from the model as such. I mean, I know it is just fitting a simple linear model around a very complex nonlinear model. So that is the whole idea behind the explanation.
We have a question there.
Yeah.
Hi, so the question is that you said it is not model agnostic. So which models does it support? And then how is it different from a decision tree or a regression model where you get all of those decision nodes, right?
Yeah.
A decision tree also explains the whole thing actually. And also a regression model gives you the coefficients actually. So how is this different from that? And thirdly, is this a free tool and an open source tool that anyone can use?
Sorry, I didn't get your last question. It is free and open source. It is Apache 2 licensed. So did I answer that? So for the first question, yes. So actually for now, it is for decision trees. It is for random forests. That is the version that is on GitHub. We will soon open it up for gradient boosting and SVMs, which are specific to Apache Spark. So we have written this on top of Apache Spark. And so yes, how different is it from other linear systems? It is basically a linear system. So it is around your query, you try to build that linear system on that. So that's it.
Question here.
Yeah.
What would an explanation for, say, image look like?
Yes. So basically, when it comes to interpretability, so here interpretability is a mere, in this case, interpretability is a mere the value of this, right? But in text, you cannot give him a single word and say this is the problem. But in an image, you cannot give him a single pixel and give him that this is the problem. So you'll have to give him a patch of image. So let's say is this picture a cat or not? So you'll have to give him some a reasonable subset of the pixels so that it shows something like a cat eye. Same goes with text. Let's say you're trying to predict if it is going to be, let's say you're doing a sentiment analysis. So this product is so good. So that would be a reasonable explanation than this our product. So here it is just presence or absence of that variable, but there it could be a group. That is it.
I see it.
Hi. I'd like to ask, how would, if I just extract rules from a cart model,
yes.
How would this be different from it?
Yes, that was the housing price example. So your rules could be for a global explanation. So you could say your size in square feet would heavily contribute to the result, but not for that particular query. For that particular query with, let me show you that. Yeah, for that particular query with 600 square feet ultra luxury villa, that square feet is not the variable that is going to be your result. It's about that ultra luxury thing. So that is where the difference between global and local comes in. So the variables you select for each and every individual query could be different. That is what we are using a feature selector.
One last question.
One other confusion for me is in that big picture. You have the scaling and sampled weights that feed into the lasso regressor. Can you explain that? Because you're taking one data point, how does the scaling and this sample weights, how much data point does the lasso regressor have? Do you run the regression model at the time of for that data point? So that would really help.
Right.
Thanks.
So basically we put them into discrete buckets. So now we have a toned down data set that is residing along with the model. And here you have a query as well. Now you are trying to place this query into any of those buckets. So the closer the bucket, the more it weight gets. Let's say you have variables, you have 10 buckets, 1 to 10, 10 to 20, up to 100. Your number is 25. So it is more close to the 20 to 30 bucket. So there you get the weights. And now you also get in this weighted data, you also get the class probabilities from the model. The probability of that class being a result in a classification case. So you also have that. Now you try to, basically we use these regression and selector tools to reduce the number of features so that we get only the most contributing variables. So that is why we have a twofold case. One is a chi-square selector, which can select the features, and one is a regressor, which will in another way give me the probability of those weights. So combining this would be a compelling result. Actually, we could skip out one of the two. So now we are able to get a prediction in about 100 milliseconds. So in case there is a demand for very quick responses, then we'll have to tone down one of the two. So that was one of the reasons we made it non-model agnostic. Because if it is model agnostic, then we'll have to look up the entire training data set for each and every query, which is not good for a production system.
Thank you. Thanks, Ram.
Thank you.
So next we have a stretching session by Lochin. I guess all of you must be tired sitting at the conferences since the morning, so let's flex our muscles a little.
Check. Check.
There are some seats here for people who want to sit. And also we have the OTR session going on in room 01. That is just to the left of this hall. The session is about using open data in different scenarios and the challenges and opportunities around the same.
Hey guys, I'm back. It's too bad most people are leaving now. Anyway, so, all right, so can we stand up again, please? Yeah, it's probably not the best. Check. Yeah. Okay. So sound better? Okay. Awesome. All right, how are we doing on energy? Good. Can I see more thumbs up or thumbs down? Good. Like not quite there, sleepy. This, yeah. Okay, fair enough. Okay, so let's fix that the best we can, right? So again, I'd like you guys to breathe a little. Something that we often ignore. And before I continue, I'd like you to talk about, I'd like to talk about what good breathing is, what efficient use of our lungs really is. Okay, so what I'd like you to do is take one hand and place it on your chest, and the other and place it on your belly. Okay, now I just want you to find out for yourself, close your eyes if you can. I want you to find out, when you breathe, What exactly is happening? What hand is going ahead? What is not moving? Just figure out what is working for you. Take a nice deep breath and feel what good breathing could be. See what you're using. See if you're using your chest a lot more than your belly, or the other way. Okay, now that you've done that, let me just tell you that it's important to breathe a good deep breath to make, obviously, most use of your lungs to the extent that you have enough oxygen going around your body, right? And also getting all the nutrients where they should go to the cells. All right, so then in the same position, I'd like you to breathe in first. As you breathe in, take a nice deep breath into your chest first. Once your chest is full, I'd like you to breathe so your belly comes out. And as you breathe out, I want you to do the same thing the other way around. So when you exhale, you first breathe out at the level of your chest, your thorax, and then down in your belly. Push all the air out. And again, breathe in, chest first out, belly next. Breathe out, chest in, belly in. Okay? Once you have this figured, I'd like you to do this more often if you can, where you work. Because if you don't have the time or the space to stretch, the least you could do is breathe well. Okay? Now, let's move. I think I last stopped at the level of the shoulder with you guys. So now, let's just raise one hand. Your right. Okay? And get it over, across. So your elbow almost meets your left shoulder, like so. Okay? And you're not pushing too hard, you're just seeing how far you can go. Okay? And I want you to forget, or rather not forget, to breathe. Okay? You need to hold your stretch here a little. Yeah? Okay. Now the other side. Yeah? Nice. Now feel the muscles being worked out. It's not doing it passively, but also like thinking and feeling about what is being engaged, right? Okay, now we move to doing this. So you shoot your elbow up, and then you basically force as little as possible, gradually, your elbow down. Okay, and I want you to keep it there. Okay. Right. Now, just to add a bit of a challenge here, you could take your other hand and sort of just hold that if you can. Is that possible? Okay. And now to the other side, again, just as slowly. Okay. Excellent. All right, next. Again, I'd like you to, this time, place one hand on your thighs, say your right hand, okay? And I want you to stretch your other hand, your left hand, up above. As you breathe out, you go to the other side, okay? And this is a lateral movement. You're not going forwards, you're not bending backwards. It's a very straightforward lateral bend, okay? Try and get your hands as close to your ear as possible. And again, it's about staying there for a bit. Not pushing yourself too hard, as far as you can go. If it's until here, it's still cool. Okay? This is also called Ardha Kati Chakrasana in yoga. Okay, now the other side. Down. As you breathe out. Right? And you feel the stretch here, and you feel the contraction on the other side. Stay and off. All right, you guys have probably seen this next movement. It's a hip roll. So you either hold yourself like this or like this to support your back, your lower back, and you Your feet are about hip width apart, and you go clockwise. Again, this is not like a crazy swing like this. All right, so it's about keeping your head steady and just moving your hips. Okay? And try to keep your head steady there. Just imagine you're holding it. Okay? The other direction now. Okay. Okay, how are we doing on time? How much time do I have? Almost done? Okay. Okay, I'll take you through some exercises for your wrist and your hands so you don't suffer from injuries that are particularly, yeah, don't go crazy with that, man. It's cool. So just keep your hands in front of you. Okay. Raise and lower. Raise and lower. Raise, lower. Engage it. Raise, lower. Do it with some feeling as well. Raise, lower. Okay. Raise. Now make a fist. Clasp it tight. And release. Fist. And release. Fist. And release. Now hold your right set of fingers and pull towards you. Okay. Now take your right thumb and pull it towards your upper arm. Like this pretty much. Don't force it. I mean, you don't want to worsen things here. That's the last thing you want. No fingers, no coding, right? Okay. Okay, so do the same thing with your left hand, and I'll take you through the next set of exercises. Bye.
Thanks, Lochin. Hope you guys are all flexed out and ready for the next talk. We have Charumitra Pujari from Paytm talking about how to go from a recommendation carousel to personalizing the entire app and how they did this at Paytm.
Yeah, I'll just, is it on? Is it on? Should be on. Hello? Can you guys hear me? Perfect. All right. Hi, guys. My name is Charu. I work for Paytm. I manage all the data science and machine learning teams at Paytm and build several products there. Today, I'm going to talk about the personalization story at Paytm, right? So I'm going to talk about our journey, which we have taken in about last year and a half. I want to tell you state of the union, where we are at, where we are going. And we'll also talk about, different points in time, how did we pivot, and how did we go about building whatever we have today in terms of personalization. So agenda is very simple. So we will talk about why do we care about personalization at Paytm. It seems like it's a very large payments company. Um, then we will talk about the evolution of how did we just describing you our journey, and then finally how we engineered a very large scale personalization system, right? Okay. Something about our scale, most of you have heard about us. I'm assuming most people know what Paytm is. If you had lunch today, you could have actually paid using the QR code solution um, uh, that we built. So something about our scale, we have 100 million plus products, and we work in over 2,000 categories, and it's a very wide variety. We go right from marketplace product like e-commerce products, cell phone covers, to fashion accessories. Then we sell travel tickets, we sell movie tickets, we um, we enable a lot of offline payments, um, we sell deals. Name a category, we probably have it, right? So that's why we have very large number of categories and hence very large product set. We have about 100,000 sellers in marketplace alone and about 6 million plus offline merchants. And the reason I'm talking about these numbers is not to advertise, but to tell you about the scale, right? So when you have a scale like this, most of most of the out-of-box recommender systems, whatever people have done in past, kind of starts failing, right? So even your standard databases, standard technologies that you can use to build these, all of that starts failing. And that's when real innovation happens, because you actually have to go and build it to match your scale, right? Obviously, we have 220 million customers. Most of you have heard this. We have 80 million plus monthly active users, which is a very huge number. That means that people are coming back on the app, back on the website, and then every time they're there, you actually have to serve them some kind of products, right? All right. So personalization at this point, at this scale, think about the categories that I talked about earlier, right? You're selling travel tickets and hotel packages on one side, which can cost you a few thousand rupees. And you're selling a fashion accessory or bazaar products, if some of you have been shopping at Paytm, which can cost you tens of rupees or a few hundred rupees, right? That's such a huge variety. So how do I actually rationalize what should go on my homepage? How do I rationalize what should go on individual category pages? How do I actually start driving traffic to each one of these pages? It is a very difficult problem to solve. So variety of offering is our number one reason. Number two is when we talk about marketplace itself, we have a very long tail assortment of products, right? So we have roughly 100 million plus products in our marketplace catalog alone, coming out of 100,000 merchants, which basically means that not every product is going to sell. Some of the products won't even sell once in a year, right? And this is actually a typical retail problem. It is, it is not unique to us. The uniqueness here is in the scale, right? Then transaction is king, right? So I mean, we are not a content website. So today we are not a content website. So it's not like I want you to come and spend half an hour every day on the website. I want you to come and do a transaction, and I want to make that experience so seamless for you that when you come, I know why you have come here, and I basically show that to you upfront so that you can actually just come, do your transaction, and get out. I don't want to come in your way. That's the whole idea. And then, like I said earlier, in any digital business, basically you always have, again, a long tail of properties also, right? So you have a long tail of products, you have a long tail of properties. What that means is you will have very few properties which are very impactful. People can come there, and people will keep coming there, like your homepage, typically. That's a very attractive proposition. But as you go down in the tree, there will be some pages which will get, let's say if your homepage is getting a 10 million views per day, some of your other pages will get traffic of, let's say, 100 views in that particular day, right? So that's why the premium properties are limited, and it is kind of an obligation for us to make sure whatever we are putting on our premium properties is something which is very, very useful for our customers. By the way, putting something on our premium property can make or break a business, right? So we have to be very cautious about that. And this is exactly why personalization was not like a fashion V4 type of a product. It is a RAM necessity for us. All right, let's talk about, so we started this journey somewhere around 2016, early 2016, right? And that's when we were having a lot of discussion. So what do you mean by personalization? What are you going to do? So we said, I come from a background where I have been trained to set metrics against every damn thing, right? So I mean, whatever I do, I try to set a metric against that. So because everything should be measurable, right? So we said, let's set some metrics first. And then with the help of some marketing guys, we actually put some nice words also around it. And that's what I have on the slides here. So number one objective was customer delight, right? So the simple metric against this is basically if the customers who are coming in are actually doing the transaction or not. So if customer will like it, they will obviously do a transaction. If they know that they don't have to spend a lot of time, and once they are on the app or once they are on the website, they can see the product that they need, they will obviously buy, right? So that's the first one. So we want to make sure that we are showing the products preemptively to the customers, and not everything needs to go through search, because search is again a multi-hop process, and you don't want your customers to go through that pain, right? And remember, like I said earlier, transaction is king. My objective is that you come in and I should show you what you are here for. You should do your transaction and you should be able to move on, right? We should show relevant products to a customer based on the prior purchase behavior. This is more like a how. Then the second one is seller delight, right? We have so many sellers. We are a two-sided marketplace. So we have equal amount of respect for the sellers also. Like I said earlier, if I put a product on a homepage, it can make or break a business, right? So what that means is that I need to make sure that I am being equally just to my sellers, and I'm giving them an equal opportunity to sell on our platform, because that's what the purpose of a marketplace is. Marketplaces are not meant for one or two sellers to sell the whole thing. And in that regard, we truly believe in that. And the metric that we set around that was the overall spread that a seller gets. So in my top row on my homepage, top product row on my homepage, I can literally measure at the end of every day, every week, every month, how many sellers did I end up promoting. And we will come to how personalization actually made it possible. And then third one is obviously our business objectives, right? So my category managers, my business growth managers, I cannot leave them alone. They are an equally important entity in this trinity. So we actually call this a trinity, a triangle. This has come from our CEO. So there is a Paytm triangle, which is customer, seller, and then Paytm business objectives, right? So the Paytm business objectives are, in a month, it could be I want to drive a lot of transactions. In some other month, I want to drive a lot of GMV. In some other month, I may want to drive a lot of click-throughs. And that will be driven by what do I want to achieve in that particular month, right? So I have to whatever I'm building, I have to build it in a way that I can kind of respect that. So remember, customer, so I have to make sure that customers are happy and they are getting what they need. I want to make sure that the sellers are happy and they are actually able to sell, and it's a just marketplace. And Paytm business objectives, which is basically I want to make sure that by making sure that both of them are happy, but we still need to make sure that whatever we want to drive, we are also able to drive that. Cool. I want to talk about, let's talk about the evolution of personalization now, and then maybe I can just go and talk about where we are at. So again, we started this journey somewhere in 2016, and that's when I was given one top carousel on homepage. It's popularly called as EDD. Internally, it's basically, the name of that list was exclusive discount deals. And I will talk about how we used to build assortment for that, but basically this is a property where we get a lot of clicks and obviously a lot of visibility, right? And the way to build it was people would go in, they will find some of the best deals, and they will just put it here, right? So we started with that single carousel. Then we said, oh, it's working out. We tested it, we measured it. We'll talk about the measurement journey also. And we said, okay, now why don't I just put it on all the other high traffic properties also? So let me just pick up one high traffic property after other, which is called a category landing page. As an example, you can go paytm.com/electronics, and that will take you on the electronics homepage. And we just started taking one carousel by one carousel on that also. So notice the difference here though, right? If you go to most of the e-commerce companies, they go by a different approach. The general approach is go by the Amazon way. And the Amazon way is that I am going to go in a widget fashion. What that means is that I will build 2 or 3 different types of algorithms. So we took a lot of input, how the scientific measurements are done, and we actually baked all of that into our measurements platform. And now, if a customer is getting same type of treatment, then they will continue to get that same treatment across the board so that they are not really polluting the experiment. And initially, I was a bit hesitant in doing all that, but now I think that was a great thing that we did, and we have seen really good results because of that. So we built experimentation service. Then we went on and we did real-time data for evaluating experiments. And we built a really cool reporting tool. I have a few folks here sitting from our data lake team who actually helped us build the reporting solution. And now we can literally see all of this data in near real time. And the next step of this that we took recently is portfolio balancing. So we had another guy who came from financial math background, and he was like, you know what? In financial math, basically in people who are doing stocks, their best thing is that the best wish that they have is basically can they actually go and rebalance their portfolio very quickly, right? So they want to see if some experiment or some algorithm is running, and then can they actually go back and they can try and rebalance the portfolio. If this experiment is not working, let me reduce it. Let me increase another experiment which is working. And it is very expensive there, right? Because you always have to pay fees to rebalance your portfolio. I told him, why don't you try it here? It's free. And he did it, right? So what we do, which is also called some kind of multi-arm bandit, by the way, is that we run multiple experiments, right? So we run, I want to say we run about 6,000 experiments in a day across different types of lists, because we run about 2,000 lists, and every list has at least 2 to 3 experiments running at any given point. We are comparing them in real time, right? And at every hour, if I know that this particular experiment is not working on a particular list, then I will start decreasing the exposure of that model on that particular list, and I will start increasing some other experiment. And I really like this, because when we will talk about, I don't think I talk a lot about adoption challenges here. I will talk about that in the end, but this was one of the pivot points that really helped me get adoption of machine learning. People don't believe in machine learning, right? In any organization, it is a very hard thing. And I'm not saying that only for my current company. I've been doing this for 10 years, and I have fought this battle multiple times, right? It is hard to convince growth managers, category managers, business managers that, hey, and actually us also, when the self-driving cars will come, it is very hard for me to digest the fact that I can go completely hands-off on a self-driving car. Same way they think about it. They're like, I'm not going to go completely hands-off. This is my business, and you know what? I am actually going to get bonused on if my category is going to do well or not. So they don't let you go full throttle. It's the same self-driving car problem, right? So this type of a thing, portfolio balancing helps you, because what you do is you ask them, well, you don't have to go, you don't have to be completely off the hook. And what you do is, why don't you go and curate a list based on whatever assumptions you have, whatever mental model you have, and then we will run it in real time. And then if you are winning, then I should obviously give you more credit, and I should increase the exposure. And once I do that, and I've seen this, and I've not just seen this here, I've seen this earlier also in other places I worked, that once you have once you have built that kind of a rapport, once you have given them the tools like this, then basically the confidence comes and exposure increases. Okay. And the third one is the most interesting one, right? We started with notebooks, and that was my foolish idea. So we started writing our entire pipeline. So we were churning about 20 terabytes of data at that point, building the model, first gathering all the data, building the features, and then building the model, and then saving the model, and scoring the model. All of that was done in this very nice notebook environment, which is called Databricks. Databricks was a very new product at the time, right? So it has matured a lot since then. And then, oh, we have scored everything. And now, you know what? If you want to put it in production, you got to run it every day, man. So how do I do that? So I wrote a very simple scheduler. It used to come with a cron scheduler. We just utilized that. And then we started writing some scripts to basically augment it. And, and then we wrote a scheduler. And then I took a flight to India. By the way, I'm based out of Toronto. We have a fairly large data science lab there, and that's where we have built all of this. I took a flight to Toronto. I'm going to launch it. And then midway from London, I get a call that, oh, by the way, this is not working because the notebooks are actually not meant for it, and it just cannot handle the scale. And I returned back. But the thing there is that it is an amazing learning from that never again in my life, when I will build something like that, I will underestimate the engineering aspect of it. So I did not underestimate the engineering aspect from the point of view that, oh, you should build solid pipelines. You should understand how you're going to put it in production. But when you have to do it, when you have to build these production systems, you have to build it properly, right? That was the learning. So we built it in notebooks. It failed. In 2 weeks, we actually converted into Spark jobs. And that was an easy thing for us. And then in the first version of it, we basically used Elasticsearch to serve this. We had a very tight integration with our catalog as a serving layer, and we were using that, right? Then we basically started building personalization. We built this personalization service so that there was some more learnings of this tight integration. So we built personalization service, which again, I'll talk about that in a bit. And then finally, we ended up building this real-time scoring thing. So where are we at today, right? So we are personalization everywhere. I think I have repeated this a few times. So we always reach out to customer with very personalized list based on some custom assortment. We can people don't have to time share list. Earlier, people were time sharing list, right? So a fashion accessories and a shoes guy will do this together. Basically, they will try to put same products in the same list and so on, right? I don't think it matters. Okay, this is another learning, right? So anytime we have built models, basically I try to take some. We always try to infer some things from how it is actually done in today's world, and then see if you can build intelligent systems that can actually do it. Now, in typical world, for any product list like this, exclusive discount deals, anyone who is configuring that, they always start from some catalog, they select some pool of products, and they try to push it there. It's a mental model which does not capture a lot of complexity, and hence it cannot be generalized, right? And you will always have dependency on humans to reproduce it. So now I want to talk about the personalization framework that we have, right? And this is very standard framework that we have tried to use across different things. And the only time something evolves is basically different types of models. And the framework is so general that you can mix and match different types of things. All right, it obviously starts with data lake because that's where you are capturing all the data. The first step that we do is product pool selection, right? This is a very cool forecasting algorithm that we have built. And over the period of time, I would say it has gone through 4 or 5 iterations maybe. I have gentlemen here in the crowd who actually built it. So what we do here is we start with the catalog, and basically we take, we build a very large time series of every product, right? So for every product, how much it sold in last 1 month, 2 months, 3 months, and so on. Actually, we do it on days level, right? And then we try to predict, if I were to give X amount of stimulation to this product, how much it will sell, right? So it is based on some time lag variables. It is based on visibility. It is based on how much visibility I'm giving, how much search terms were there for a particular product, what is the current discount running on it today, how much does it sell when there is no discount running on it, and then if I were to give it a 10% discount, how much it will sell, 20% discount, how much. And then based on that, I basically go and look at every discount that is going to run tomorrow, and based on that, I can say that this is my approximation. It is actually going to sell 4 units. Another added complexity here, remember I told you in the beginning, any item that can go on a home page or on a prominent page can make or break the business. That's why you need to have the location of the item as a factor in this, right? So we take that into account as well. So based on that, I can basically select some products. The next thing is we define the category affinities. I told you we have 2,000 plus, precisely we have about 2,500 categories ish, where what we do is we have gone through several iterations of the model, I think 6 or 7 now. The current one being LSTM, which is being developed. LSTM is being developed now. I think we just put it in production, and before that, it was semi-connected network. Here, we are trying to predict in which category customer is going to be most interested. Because remember, I have already picked up what are the best products in that category that are going to sell, right? So I have already solved that problem. And when I start doing category predictions, which are about 2,500, I'm not talking 10 or 15 categories, I'm talking 2,500 categories. So your shoes and your socks are different categories. In fact, your sports socks and your formal socks are actually 2 different categories, right? We can do prediction. We do prediction at that level. And once I have all of that, then I use an item recommendation. I don't use item recommendation as my starting point. Item recommendation is my end point, right? This is the last point in the journey. That's the main difference. Most of the times when you talk about a recommender system, that's your starting point. Spark comes with, so Spark comes with ALS model, and all it does is basically takes your view and product signals, basically calculate the interactions, and then basically you run some kind of alternating least square method which they have implemented, and then you try to find out which product is is going to be popular if you have seen this other product. Netflix is doing that, Amazon is doing that. I think that's the most popular thing. And obviously, people have used category affinity in past, not saying we are the first ones, but people do it after the fact. What we are doing is, we are doing it before the fact. We have always focused more and more on the category. We are focused on this model, and lately from last 6 to 8 months, we've been focusing a lot on this other model also. And partially because this is actually a very high scaling challenge, item collaborative filter, right? 100 million products is a non-trivial size. After this, remember I talked about, I do assembly, because remember I talked about my third objective, which was my Paytm's business objective, which basically says that in this month, I want to increase transactions. In this month, I want to increase GMV, and so on and so forth. In this month, I want to increase profitability. How do I do that? I need to give some kind of levers. And that's where some kind of, once I have built my assortment, this is what I'm going to show to a customer. I need to re-assort it. I need to resort it. And that resorting based on the inputs that I get. And this is an optimization problem that we are trying to solve, right? A regression problem on your left, a category affinity prediction on the right, a collaborative filter, which is a kind of a matrix factorization in your middle, and then an optimization problem in the end. This is our standard framework, and this is what we use in all the places. I'm happy to go into more depth. I see I have only 12 minutes left. Okay, I'm not going to talk about this. Category model is interesting one. We started with a very simple random forest classifier. It had about 6,500 features, and we were predicting only 200 categories at that time when we started. So we said 2,500 categories, no Maven, we cannot predict that. So we said, let's go one level up. It's obviously a hierarchy, and we started predicting from that point, right? It worked out, 200 categories, the precisions were decent. The metric that we use to measure our model always is precision at K and NDCG. Then we basically said, you know, remember I said we will go on every homepage, so every category page, that's where we started building a hierarchical classifier. By the way, one thing that we added here was in Spark MLlib, you could not persist the model, especially the random forest model. We have actually built that, so we could actually persist the model, and then we could use the model if it's stable enough. So I'm happy to share that code at some point. We built this hierarchical classifier, again, does not come out of the box. We actually built it. We said, let's take all the major categories because there are subtle differences in fashion from electronics. So we started building individual models for each one of them. And then obviously it was joint probability distribution in the end if you want to predict at the at the leaf level, or if you just want to predict for that particular category, then you can just use only that model, right? Then came this this new model, right? By the way, this is a very state-of-the-art mechanism for doing category predictions used by a lot of people. It's based on a paper from Microsoft. What we did was we understand that basically user purchases are a sequence, right? It is like a sequence of words. So we use word2vec, right, to build a latent factor, a latent space in which we could represent the user purchases, right? So on the left, you basically see user purchases and views, and then we take some target purchase category and we run it through word2vec, right? And that gives me that latent space. This guy over here, this is my latent space. And then I take that latent space and then I run a logistic regression on top of that. And that is why we like to call it semi-deep learning. This is not truly deep learning because the model is not fully connected, right? So we build that, and then finally we were able to get the category prediction. This actually works on all the 2,400 categories, right? And now we have done another thing on top of this where I don't have it here, but we basically take the next generation of this model, which has been live for about 6 months now. It takes time buckets. So basically think of a very huge stacked matrix which has this this latent space. It is stacked by 0 to 2 days, 2 to 4 days, 4 to 6 days, and so on. And then it is compared against a very large target vector in the end, right? And that's how you run a logistic regression. We tried doing basically a fully connected network also using a MLP, but the thing is our data set is so huge that we just could not finish it in time. And I need to finish every model in 2 hours. If I don't, then basically I'm late for the right prediction. Basically the precision at K starts dropping. In collaborative filter, again, we use ALS, but we initially we used ALS. We give it our flavor by giving it, you know, the strength, which is the interactions. We gave it our flavor, where we said that not every interaction is equal. So we built a custom function which exponentially decayed the interaction. And now what we are doing is, and that's why I mentioned the 6 million plus offline merchants in the beginning, is because I'm introducing all the payments data in here as well, where I can literally build a function in ALS which just says that I will have X amount of weight given to interaction from a digital product and a physical purchase. I will have Y amount of weight given to a digital product and a digital purchase. I will have Z amount of weight given to a physical product and a digital purchase and so on. So I can make all those permutations, assign different weights to them, and that's how, and that's basically our variant on how do we define our interactions. This is another use case where we basically had, you know, even after doing all this, you will always have these corner cases keep coming up. This was specifically done for air conditions and TVs, high-end electronics type of categories. And what happened here was we were not showing the right products. So basically what we ended up building was another, so similar model, the semi-connected network that I showed you, we built a variant of that by using price buckets and brands, right? And this is a TSNE visualization of that. You can see the red ones are the ones which are predicted by this model, and the green ones are the ones predicted by our general model, right? And the blue is the customer's purchase. You can see that the red dots are actually in path of how customer actually purchased it. This is an interesting one because somebody actually challenged us once, and this graph is just coming from that email. We sent it to them saying that, by the way, you are buying this type of stuff, that's why we are showing you TVs which are very expensive. This is interesting. So now at every point when we start giving out a recommendation, what we do is we are not serving from one model. It really depends on the type of list that is being created. So we start with a customer, then at the time of generating the recommendation, we look at a few things. As an example, does this list have categories, multiple categories, more than 10 categories? Or is it primarily a list which has only products from electronics? Or is it primarily a list which has products from shoes and fashion accessories? That's a mixed kind of a list and so on, right? And based on that, we have built a system where we basically invoke different types of models. So it is not one model. Again, that would be another problem with using a vanilla ALS, where in a ALS, you have model, and you're trying to drive, you're trying to treat everyone through that same model, right? Whereas in this case, you can have multiple different types of models, multiple variations of deal pool selector, multiple variations of category affinity, and multiple variations of your collaborative filter, and then combine them based on the type of prediction that you want to make. Okay, I want to share some very quick results. Basically, you can see on the left, you can see some lifts in CTR. But basically, 2,000 plus lists are personalized today. We serve about 1 billion plus recommendations every day. We have seen about a 2x increase in GMV per user, similar type of increase in number of transacting users, number of units sold per user. And then we have served a lot more sellers than we would have served by doing manual assortment. This is our overall architecture. I'm just going to finish in like maybe 2 more minutes. The overall architecture is basically, we have a batch part where we do a lot of feature creation and so on. Then, let me go to the next one actually. Right. Then we have these 3 individual microservices. Going back to that framework, right? We had 3 things. So we had a deal pool selector, which is in the middle here. We had a category classifier, and we have, we call it white mage. It's basically the collaborative filter, right? These are 3 independent microservices, completely deployed with their own data sources. I can deploy whatever model I want to deploy there, and so on and so forth, right? And then we have an orchestrator, which is directly talking to something called our serving layer, which is an extension of our catalog. So our catalog, every time it wants to serve anything, it will first make a call to us. Our measurement system is going to determine what type of model needs to be served. Then basically, we will go to that particular, we will go to the orchestrator. We will tell orchestrator, pull up that model for this customer for DPS, pull up this other model for CC, pull up this other model for white mage. And then all of them send back the results to orchestrator. Orchestrator then goes to another DB, which tells it, in this particular list, my goal is to increase the transactions. So then it says, okay, so let me pick up the optimizer or the racking objective, which I need to solve for is increase transactions. It resorts everything, and then it basically sends it to sends the recommended products. And obviously we do a lot of validations like, is the inventory there or not? Is the merchant good or not? Has the merchant been blocked or not? And so on and so forth. Great. I want to share some learnings. This is my some of the things that I've learned over the last 10 years. So don't build stuff for yourself because people will not adopt it, and that will just lead to more frustration. So always build for your customer. Ask them what do they need. This is an interesting one that I've learned. Don't build things to present at conferences. Build to add value to business, right? Always do that, please. Because when you add value to the business, you will get a lot more ideas, and then you will be actually able to build something which you can present at a conference. So it works other way around. Change is hard and messy. Adoption is very, very hard. Machine learning adoption used to be even more harder 5 years ago, right? Now because AI is a buzzword, business managers are coming around. There is a top-down push, so people are adopting it, but it's hard. Find a business partner. Get executive sponsorship, but more importantly, find a business partner, and they will help you get through this, right? Engineering first. So models are absolutely useless. They have zero value
Charu,
if they cannot go
sorry
in
for
production.
interrupting you, but
Yes.
we've overshot your time.
Okay, I'm almost done. And just start small and keep iterating. Thanks, guys. Sorry it took longer.
Thanks a lot. We will not be taking Q&As for this session since the time is overshot by a lot. There's a parallel OTR session going on in room 01 outside. Move out of the hall, take a left. The session is about interesting problems to solve with data science. Also, there have been feedback forms distributed to you guys. Please rate the talks. That helps us make the conferences better. The next session is by Santosh GSK from Practo. And Santosh would be talking about adopting bandit algorithms to optimize user experiments at Practo Consulting.
Hello, hello.
Also, you need to take care that the forms distributed right now are the evening session forms. The forms which you had earlier were the afternoon session forms. So, like, there are 2 feedback forms for the same day according to time. You need to fill them both. I mean, it's not compulsory, but we would really like you if you do. The forms need to be submitted outside. There's a basket near the registration desk. You don't need to move out of the hall right now. You can do it while going out. And I hand it to Santosh.
Okay. Hello, hello. Cool. Hi, everyone. I'm Santosh, a senior data scientist at Practo. So, how many guys have heard about Practo? Awesome. How many guys have tried online consultation at Practo? Nice. So, for those who don't, Consult is an online consultation platform where a user can post a health query, and we as a platform connect it to a doctor who replies back with a medical advice. So in such a platform, if you want to optimize for a user, you would often assign all the questions to a set of doctors who are performing, who are answering a lot. But over a period of time, this set of doctors, who usually are a very small fraction, will get a lot of questions assigned. And they won't be able to answer all of them. They would feel burned out. And at the same time, the rest of the doctors would get very less questions assigned, and they won't be engaged with the platform. So if you try to optimize for the users, you would end up with a bad experience for the doctors. On the other hand, if you try to optimize for the doctors, you would randomly assign the same number of questions to each doctor. But not all doctors are equally active. Some don't even open their app to see the questions that were assigned. So those questions would obviously end up being unanswered, and would impact our user experience. So if you optimize for your doctors, you would have a bad experience for your users. So usually you come across such kind of trade-off at any marketplace, even for e-commerce sites like Flipkart or Amazon. If you try to optimize for buyers, you would have a bad experience for sellers and vice versa. So in this talk, I present how we use bandit algorithms to actually solve for such a trade-off problem. The key takeaways from this presentation are to understand how multi-arm bandits work and how you can use at any of the problems that you work on, and how we used at Practo Consult. So let's begin. So let's say we have a guy who just came to Bangalore, and he wanted to have a good dining experience. But he has no idea which restaurants are good and which are bad. So he asked a couple of his friends, and they suggested a couple of restaurants. So he went there, and he liked them. So he made two buckets. One bucket where the restaurants he liked, the other bucket which he never explored. So the next time he wants to go to a restaurant, he wants to play safe and goes to those restaurants which he liked. So more often than not, he wants to visit such restaurants, let's say out of 10 times. But he gets bored and he wants to occasionally explore new restaurants. So he goes to one of those unexplored bucket, and if he likes them, he adds it to the like restaurants. So what we are seeing here is a multi-arm bandit setting. The restaurants on the right side are your multiple arms, and the reward this guy is trying to optimize is to have a good dining experience. And the way he's trying to do that is through an exploit and explore strategy. So he's exploiting 9 out of 10 times and exploiting 1 out of 10 times so that he would not miss out on those new restaurants. This is the simplest form of multi-arm bandit algorithms. It's called as epsilon greedy, where epsilon stands for a probability. Here epsilon is 0.1, means that 10% of the times he explores and 90% he exploits. So this guy really liked this strategy. He started exploring all the restaurants. After experimentation, he was no more a stick man. So coming back, Practo has a lot of use cases for patients. Like you can search for doctors, clinics, or hospitals. You can even book an appointment, or you can consult online, or also you can order medicines. So the one use case where you're looking here is consultation online. A usual consultation form looks like this, where you post your problem. Also, you select a problem area in which specialty you want this question to be asked. So we only send this question to those doctors from that specialty. Once the question gets posted, we now have the task of assigning to a doctors that we have in our list. So let's say today we have with us doctors Shyam, Alexa, Ram, and Bob. So if you can see, Bob looks like a surgeon, looks like to be more busier than other doctors. So somehow we have figured out their timings. And if you look at their availabilities, Shyam is available on weekends, Alexa on evenings, Ram on mornings. But Bob, he has a lot of surgeries scheduled for that week. He's just busy for that week. So let's say this question comes on a Wednesday morning. Even if, let's say, hypothetical Shyam is the most performing doctor, we won't assign it to Shyam because he is not available on the weekdays. So we assign this question to Ram instead because he is available on mornings. So this kind of using the context is what we call as contextual assignments. So how we do that? For every question, we build what we call as a contextual feature vector. The features can be the number of words, the time the question came in, the age and gender, etc. And we multiply that contextual feature vector with parameter vector of each doctor to get what we call as a predicted reward. A predicted reward is nothing but how likely this doctor would be giving you a fastest response. The higher the reward, the faster the response you can get from the doctor. So it's straightforward. You can just pick the doctor who has the highest reward, assign the question to him. So here in our case, Ram has the highest predicted reward, so you assign the question to him. But the important question is, how do you estimate the parameter vectors? We look at the previous assignments made to the doctor, and we look at what are the true rewards we got from that doctor. We then apply a simple ridge regression to estimate the parameter vectors. So all is good, and we made few assignments over a period of time. We observed that Bob has got very few assignments compared to other doctors. So if you see, Shyam has got 30, Alexa 50 and 45, and Bob has got only 9, because he was not answering a lot of them. So this doesn't mean that Bob won't be answering questions at all. He's just busy for the week, so we should give him more chances. So let's give Bob few more chances. How do we do that? So let's say you got a new question on a Sunday afternoon. So using the contextual feature vectors, we have calculated the contextual predictor rewards here. Now, along with that, we calculate now what we call as a regret bound. A regret bound is nothing but it shows how less information you know about the doctor. The lesser the information, the higher the regret bound. So in this case, Bob has a very few assignments. So we don't know much information about Bob, so the regret bound is higher. So we add this regret bound to the contextual rewards that we already predicted, sum it up, and pick the best. So now Bob would get a chance to answer. This is a second algorithm in multi-arm bandits. It's called as upper confidence bound. If you're familiar with statistics, it's very similar to you giving an estimate of a parameter, u plus or minus sigma. The lesser the information you know, the lesser the sample size, the higher the confidence interval you have, because you're not sure of the parameter value. Similarly here, you're not sure of Bob, so you have a higher regret bound. So we have implemented this algorithm, and some of the results we see was, with the random initialization of weights, we were able to see a 60% reduction in response times within 10 days. Also, interestingly, we were seeing a 25% reduction, sorry, 25% increase in engagement of the doctors, which means that we are able to tap into those doctors who are actually participating with the platform, and we are able to assign more questions to them. That's for the consult. Let's see some of the use cases where you can apply bandit algorithms. So one of the common use cases people refer is with A/B testing. So your user comes to your platform, you have two versions of your website. Let's say you know the true conversions, which is like 0.3 and 0.2. Let's compare A/B testing with the simplest multi-arm bandit algorithm, which is epsilon greedy. So here the blue curve represents the average conversion of epsilon greedy, and the green curve represents the average conversion of A/B testing. So for those who don't know about A/B testing is a place where you run an experiment for X number of trials. You randomly show one version to each user. After you finish the X trials, you pick the version which has the most conversion rate. So as A/B testing was doing a random assignments, the average conversion was lower than epsilon greedy. Epsilon greedy being the dumbest of all the multi-arm bandits was still able to perform better than A/B testing. But after 1,000 trials, A/B testing starts to perform better because it picks the best version, which was version A, and shows that to every user. However, our epsilon greedy is still exploring 10% of the traffic randomly to each one of the versions. So there are 2 points that we can take from here. If the behavior in the versions changes, it's good that we explore, and the bandit algorithms would be able to adapt to those changes in the version. On the other hand, there are methods in bandit algorithms like annealing, which will make you explore less as you collect more data, so that you can optimize this graph over A/B testing. Some of the other applications are, if you want to send user notifications and you don't know what time to send, so you can apply bandit algorithms to come up with a personalized time for each user. And similarly, news recommendations. So you might be like pretty much across most of the data science journals, so you would be seeing a lot of data science articles. But what if you're interested in Bitcoins and never come across such articles? So bandit algorithms would occasionally explore your interest in new areas which you had never seen before. And if you like them, you would be like exploring new areas. So if anyone from the audience are from InShorts, you have a cool new project to try. So these are the two references. For anyone who wants to get into multi-arm bandits, Bandit Algorithms for Website Optimization is a very good starter book written by John Miles White. And the paper, A Contextual Bandit Approach to Personalized News Article, is the one that we have implemented. So lastly, when to use or not use bandits. So if you have a short experiment, like a Facebook campaign or a marketing campaign, and you have a couple of different versions to experiment. Let's say you have a message like sign up and get 30% off, or please sign up and get a discount of 30%. and you don't know which of these versions would give you a maximum conversions. You don't have time to run an A/B test and come up with a better version. So instead, if you put bandit algorithms there, it automatically optimizes for the better version and redirects the traffic to that version. Also, if you have continuous experiments, like in Consult, we have doctors who keep adding, who keep moving away from the platform, or their behavior keep changing, as we were looking at Bob. So if such a case, is there, you can use bandit algorithm, which continuously adapts and tries to optimize for the conversion. So when not to use for bandits is when you want to run any test and want to infer which version is better than the other. So usually bandit doesn't care about what is the version, it just cares about the conversion. So A/B testing should be preferred there. And like one example is clinical trials. Yeah, that's it.
Questions?
So you mentioned about the bandit algorithm and the A/B testing, where the trials, where A/B testing started improving after a certain number of time frame in one of the slides.
Yeah.
Right. So when do you think what do you tell as a cutoff that you will say that I want to switch from A/B to bandit, or what is the time frame that I'm looking at?
Usually it's used as an alternative to A/B testing. So A/B test, all it does is it finds out that version which has the highest conversion and just shows that to 100% of your traffic. But do we need to show that same version for every user? Maybe the other version is close enough, or maybe if you use more traffic, the second version might be better than the first version. So bandit algorithms tries to adapt to that. So instead of A/B testing, it's an alternative to implement. It's not like after A/B you can use bandit. Yeah. Yes. That's a random example, but the number of samples depends on the power of the test you want to have. The difference between the options, if both the versions of your website are roughly the same, then you need to look at more data to make a conclusion which version is better. So bandit would be better because it automatically tries to maximize for the conversions. It doesn't look at which version is coming out to be good. But if you want to have a stable website where you just want to have one stable version, then you can choose A/B testing and like have that version.
We'll take another question. You can take this offline. Any questions?
So basically, when the algorithm converges, it's more or less like an A/B testing, right?
I'm sorry?
No, when the algorithm converges, so then it's essentially the performance would be like A/B testing.
So when the algorithm converges, you would still be having some amount of exploration happening in bandit algorithms. Always you would have some percentage of traffic which would be assigned a random page or a lesser efficient page, just in case the behavior changes. You can set that. You can actually set that in the bandit algorithms to explore less as you collect more data.
More questions?
Hi. My question's about the exploration probability. 2 points. One is, how do you determine the rate that you reduce the exploration probability? How do you determine that over time? And the second, how does the context of the problem influence the size of the exploration probability? For instance, if it's about news, in some ways people might have more of an inclination to explore more, so they'll tolerate,
I didn't get your second question. Sorry.
So the size of the exploration probability, how do you think about the influence of the context of the problem on that size?
Okay.
So if you take news, for instance, news are probably be more open.
Yeah.
Say, 1 out of 5 to have a random article. It doesn't hurt me that much.
Right.
And there's every chance that it's something that's exciting. But say in something like getting medical advice,
Right.
you know, 1 out of 5 cases, if you give me a doctor who's not the best qualified to answer that problem,
yeah,
you know, I'm probably going to be more upset about that, or it's
Yeah.
going to do more damage.
Yeah.
So how do you think about the context influencing the exploration probability?
So if I understand you right, how do we define the exploration probability based on the context? So how does it shrink over time? So if you are sure that all the arms, all the multiple arms has got enough samples, so you can have simple measure like you can use any log of n or anything very simple like entropy, anything, which can give you some measure of how much data has already been seen. If you have like 1,000 samples or 2,000 samples already collected, that can give you a measure of how much exploration has already done. Based on that, you can reduce the exploration probability. So let's say 0.1 divided by log of n, something like that. It keeps decreasing as the n keeps increasing. So the second question, it depends on the context and the conversion probability. So how critical is your conversion probability? In a healthcare scenario, the conversion probability might be super critical than other contexts. So depends on the use case.
Last question, anyone? Cool. I guess that's it then. Thank you, Santosh. That was a great talk. So now we're going to take a short 30-minute break for evening tea. We will reconvene at the hall at 4:10 p.m. sharp when we will start an ethics, an OTR on ethics in machine learning, which will have fairness, accountability, and transparency in machine learning. Also, there are dinner tickets available at the Hasgeek counter. The price is 3,000 rupees, and you get access to dinner and networking with the speakers. The dinner is at Blue O Bowling Center in Phoenix Market City, Whitefield. And remember to bring your badges for registration and check-in tomorrow morning. Fresh badges will not be issued tomorrow. And submit your conference feedback at the Hasgeek counters. Your feedbacks helps us make the conference better. I have also information about a lost login code device. If you know somebody with a lost device that generates login codes, it's from a brand called Gemalto. So you could redirect them to the Hasgeek staff and volunteers. We'll return that device. Thank you.